I just want to tell you that the first section of my course is about TypeScript and RxJS. And here you want for sure to say, okay, but I don't really care about RxJS or TypeScript, I want to prepare for my Angular interview. And the main point is that TypeScript and RxJS are two main building blocks of Angular, and you can't really know and use Angular on a good level without using both TypeScript and RxJS. Additionally to that, inside Angular section we will use a lot TypeScript and RxJS because this is how Angular intended to be used. If you are 100% sure that you know everything that is needed inside TypeScript and RxJS, then sure you can skip these two sections and just jump inside Angular. But at least I highly recommend you to look on the titles on the videos and check if you really know everything that is needed for the interviews. The most popular question that you can get about TypeScript inside Angular is why is TypeScript needed inside Angular and what is pros and cons of TypeScript. So here you need to answer that TypeScript is the most popular statically typed language which is built around JavaScript, which actually means we have exactly the same syntax like inside JavaScript, but we're adding static typing to this, which actually means we're not getting errors just like inside runtime with JavaScript, we're getting them in transpilation time when we're transpiling TypeScript to JavaScript. And it is important to mention that you can't use TypeScript directly in browsers. There we can use just JavaScript. This is why we must always transpile our TypeScript code to JavaScript code. So getting transpilation errors is the most important benefit of TypeScript. Secondly, it is easier to scale our code because we are breaking less things. Typically, if you just refactor your JavaScript application, you will break something for sure, because you can see your error just in runtime, but not in transpiling time. Also, typically you will see your TypeScript error directly inside your editor, even not in your terminal, which makes development much faster. And last but not least, TypeScript helps us to define entities. If we are talking just about JavaScript, there we have just arrays and objects. We don't have anything else to define and write what we have inside our applications. Inside TypeScript, we have different data types to describe what we have inside our application. For example, we can create an interface for the user, and then in every single place of our application, we don't simply write an object with ID and name, but we define it as a user interface, which actually means TypeScript allows us, with the usage of typing, to define entities and work with entities across your application. And this approach is much more stable and easier to read. And if you are being asked what are cons of using TypeScript, first of all is the level of entrance. If you are simply a beginner, it is much more difficult to start with TypeScript because additionally to all JavaScript knowledge, you must learn typings and it is not an easy task. Another problem I already mentioned, we can't really execute TypeScript directly in the browser, which means we must always transpile our TypeScript code to JavaScript code, and it can take quite a lot of time if your project is really huge. You might get a question to understand if you know something regarding TypeScript interfaces. And as you can see, our question is written like so. Define a user interface with ID, string, name string, age is number, and a method getMessage that must return a string. Write a usage example of this interface. So let's try to do this now. First of all, we must define an interface, but before we will do that, you can also get a question, what is an interface in TypeScript at all? And actually this is a possibility to describe some object with data that we can reuse everywhere. And this is exactly what we need to do here. We must define a user interface, and this is a special typing that we will reuse across the whole application, and we will show if we are using this typing, it must have inside this ID, name and age of these specified types. So in order to define our user interface, typically you will write it like this. We're exporting interface, here is user interface, and this is an object. And inside we are defining first of all an ID, we know that this is a string, secondly name, it is also string, and last one is age, here we have a number. But additionally here we must define a get message, so let's add here get message, which is a method, this is why here round brackets, and here we must specify what this method returns. And as you can see in the task we are getting a string, so here we are writing just a string. So this is how you typically define an interface. And if you're asking why here we wrote a word export, this is because we want this interface to be used across the whole application and not just in this file. This is why here we're using export, so we can import it everywhere. And now we must write an example of usage of such interface. So typically somewhere inside your code you will create a variable user, and you really want to be sure that it specifies our user interface. This is why here we are saying that our user must be a user interface. And after saving you can directly see here an error. Type object, and this is an empty object, is missing the following properties of type user interface. It is ID, name, age, and get message, which actually means now we're on the safe side and we're 100% sure that this object that we're creating here will be validated against our interface. This is why here inside we can define, for example, ID is a string. Now here we have a name, for example, user foo, then we have age, maybe 30 years old, and here get message, and our get message, as you can see, is a function which must return string. Here we should not write anything and we can simply return any string that we want, but we can make it nicer and just write here a name of our user, so this name space is space this age. So we successfully wrote the example of our interface, and most importantly now here we can't throw any additional properties. For example, I can't write here bar, because in this case here our interface is not satisfied, and here we can't get a bar property in our user interface. Another question that you might get about TypeScript is regarding arrays. And here we have a task, how to define an array in TypeScript, show always. And actually inside TypeScript we have just two possibilities to define an array. First of all, here let's create an array, for example fruits, and we are saying that this is an array of strings. This is why here our type is string, and here we are putting brackets to say that this is an array. And now here we can define an array, like for example apple, orange, banana. So this is the first and the recommended approach to create an array. Another approach will be that instead of string array, we're saying here word array, and inside the tag we're writing the type, and in our case it is a string. And essentially this line is exactly the same like the first line, but it is different. Here we're saying that we have an array of string, but here we're saying that we're using generic type array to define the type of our array. And we will talk about generics in one of later videos, so stay tuned. And the second question that we're getting here is how to define an array of numbers and strings. And actually, in order to answer that question, you must know how to create OR inside TypeScript. And actually, if you want to define OR, typically you write something like this. You have a property foo, and the type of it is either string or number. And exactly this pipe is our number. This is why here we can set 0 and we can set here foo string and we won't get any error. Exactly the same we're getting with arrays. So here let's create an array of our values, and here we can define that we have a string or number, just like it is inside task, of array, which actually means this is what we're getting inside array. And here we're defining with brackets that this type is an array. Now here we can create our array and write here, for example, apple, then 2, then maybe orange, and 3. And as you can see, we don't have any errors because it is possible to have string and number inside an array. But if you want to show that you are a really good developer, you must mention that this is a bad practice to have different data types inside a single array of objects, because then it is much more difficult to transform this data or validate them. So inside real application, I will always question if I see code like this, string or number. It is always better to have either strings or either numbers, or maybe your user interface if you are using that. Another question that you might get is how to fix this code. And as you can see here on the bottom, we have a function where we're getting an error. Object is possibly undefined. And actually you either get such task or you just get a plain question what is type assertion inside TypeScript. And actually here you must tell that type assertion means that we're forcing TypeScript to take another type. Or sometimes it is not forcing but just guiding TypeScript to take correct type. And we're doing that with the keyword which is called as. So let's look on our problem here. We're getting here a function getItem where inside we're getting just a single parameter item of type number or undefined. And after this, inside this function we're trying to call on this item toString. And obviously we can call toString on the number if the data type is number, but not on the undefined. This is exactly the error that we are getting. We can't call toString if our item is undefined. This is exactly what we can see here. So how we can fix that? And this is exactly where type assertion comes into play. We can simply wrap this item with round brackets and write inside as and the type that we want, for example a number. In this case here we're saying for TypeScript, okay, I am sure that this item here is a number. You don't need to check that. And now here we can call toString function without any problem because here TypeScript is sure that this is a number. But additionally to that, if you want to show that you are a really good developer, you must say that this is the bad code. Why is that? Because here we're getting an item and it can be number or undefined. This is totally fine. What is not fine is writing code inside where we simply type asserting it to number. This is bad. We must first of all check here for the undefined and do something about it. Because here we're waiting for the undefined and then we don't have a case to write it. This is why here much better code would be something like that. If we have here an item which is undefined, so not item, then we want to return, for example, null. And in other case here we simply don't need to write anything because now it will be completely valid. TypeScript understands that with this check we're getting undefined away. And now here our item will always be a number and we don't need to type assert anything. And this is the best possible solution for this case. Another question that you can get regarding TypeScript is what is a void type, and we must write an example how we will use it. And actually void type is widely used inside TypeScript. Typically we will use it just in a single case, when our function does not return anything. What does it mean? For example, here we can define a function do something, and this is just a function without arguments. And actually here we might omit anything and just write console log do something. What does it mean? Our function does not return anything. And if here we will check do something function, we can see that this function is returning void. So by default TypeScript understands that we don't want to return anything here. But actually I highly recommend for you to always write what you want to return back. In this case here we must put colon and then void. And here we're defining that our function should not return anything. And this is really important because in this case here if we will return for example false, then we will get a warning type boolean is not assignable to type void, which is correct. The main problem if you won't write void here, but you simply return something, TypeScript will think that you really want to return something. This is why here the definition will be that doSomething function will return a boolean. And this is not what we want to return here void. So with void inside TypeScript we're defining that we don't return anything. And you could actually define a property of type void, but it doesn't really make any sense because you can't assign anything there. This is why we're not using void as a type for a variable. Another question that you might get after this is what is unknown? Write an example. And actually this is much more interesting and much more tricky, because actually not enough people are using unknown inside TypeScript. So let's look on such code. Let's define here a property vAny of type any, and here we simply assign 10. And here we are defining another property vUnknown of type unknown. And here we also assign 10. So actually we want to find out the difference between unknown and any, because they are kind of similar. So after that, I want to define a new property s1 of type string, and I want to assign here any. And after this, I want to define property s2 of type string and assign here unknown. So what will happen here? As you can see, we don't get any error in the first case. So here we have s1 string and we are assigning here any. The main point is that this variable is any, so it doesn't really matter what we will write here. It can be a number, a function, an object, an array. We won't get any TypeScript error, because just to remind you, if we're using data type any, TypeScript is completely disabled. It won't check anything. This is why here we can assign number inside string, and it doesn't make a lot of sense. What we are getting here in the second case, we are getting type unknown is not assignable to type string. What does it mean? Actually here we have the unknown property of type unknown, so we don't know the data type yet. And in this case here we assigned here a number, but we set a type unknown. And actually we want to use type unknown always instead of any. What does it mean? If we don't know what type is that, we should not write any, we should write unknown. And actually unknown data type was introduced in TypeScript 3, and I highly recommend you to use it if you are not sure what data type you have. And here is one more important point why we must stick with using unknown and not any. If I will write here console log vAny.foo, we won't get any error because our vAny is any, and we can call here whatever code and TypeScript won't say anything. But if we will try here to console log vUnknown.foo, we will get here an error because object is of type unknown and we can't just call here something with the type unknown. And at this point here you might want to ask, okay, but how do we fix this error with unknown? And for this we must use type assertion from the previous lecture. So we must use as notation to define to what data type we want to convert our unknown. In this case here, for example, we can say the unknown as string. So we won't get any error because we're assigning here a property of type string to the string, and TypeScript doesn't say anything. In this case here, if you want to call foo, you need to convert your property unknown to something which has a property foo inside. So again, to answer the question what is unknown, it is a data type which is much better than any. Why is that? Because after we used unknown, we must specify later what exactly data type we have. If we're using any, we don't need to do anything, TypeScript is just disabled. In order to check your TypeScript knowledge, you might get a bigger task. And as you can see here, we must first of all create a user interface with ID, name and age and getMessage function which returns string. Which means this is exactly what we did in the video regarding interfaces. The next point is create profile interface with name, profile URL and isActive property. And obviously name and profile URL are strings, isActive is a boolean. Then after this we must create a function which transforms user interface to profile interface. And here is a hint, the profile URL is /profile/ and here will be the name. And the last point, add optional parameter is active, so profile must be either active or inactive, and this parameter is mandatory. But here is the point, this is optional parameter, which means if it is not provided, then our profile is active. So first of all, let's start with defining our interfaces. And here I want to create an interface which is called user interface. And inside, first of all, we are defining ID, which is a string, then name is also string, age is a number. And the last one here is getMessage, which will return for us a string. After this, we must define the same interface, but for profile interface. This is why here let's define an interface which is called profile interface, and inside we have our name, which is a string, then profile URL, it is also a string, and the last one is active, which is a boolean. And as you can see here, we don't have optional fields. The last point here, add optional parameter is active, is not interesting for us, because our profile must be active if the parameter is not provided. So with that we implemented 2 points here. The third point here is to create a function which transforms user interface to profile interface. So here let's define a function with the name transform user to profile, for example, and here we're getting just a single argument, which is a user. And this is actually our user interface that we defined, and here we must specify what we're getting back, and in our case it will be profile interface. And this is an arrow function where inside we want to map all fields to the needed fields. In our case here we can simply return what we need back for our profile interface. First of all, it is a name, and we're taking it from user.name. Then we must create profile URL. Here was a hint, the string must look like this. It is /profiles, and here is going name, which actually means here we can write /profiles/ and here will be our user.name. And the last thing here is the active property. But the main point is we didn't provide it to this function. And as you can see here, we must create an optional parameter inside our function. And by default, this parameter must be set to true. This is why here we can write as a second argument our isActive property. And actually it must be Boolean type, and by default we can set it to true. In this case here we will directly assign isActive as true by default. And if we are providing it inside our function, then here it will be overwritten. But actually at this moment you might say, okay, but we didn't write that we have an optional parameter. And you might remember that inside TypeScript, to make parameters optional, we write here a question mark. But if we will try to write it like this, we will get an error. Parameter can't have question mark and initializer. What does it mean? Here we are saying that we have a default value which is true, which actually means only when we will remove this default value, then we can write here a question mark. And then this will be either undefined if it is optional, or we will provide it inside. But this is not the best approach for us because we want to set it by default in true. This is why actually this line is the optional parameter, because we don't need to provide inside our function isActive always. We can try to write it now. For example, I'm calling transform user to profile, and as you can see here, we must provide a user and isActive property. And if I will just provide here a correct user like ID, then name, for example, foo, then age 30, and get message function, which must return here foo, as you can see we're not getting an error because our second parameter isActive is optional. And you can see it from the definition. But if we need to, we can provide here a second parameter, and in our case we just need to provide a false because it is true by default. You might also get a question like this: what is tsconfig.json and what does these options do? And as you can see here on the bottom are the options that you can typically see inside tsconfig.json file. So we're using tsconfig.json to configure TypeScript compiler, which actually means if you need to configure, for example, in what ECMAScript version your TypeScript transpiles JavaScript, this is exactly the place to change your configuration. If you also want to change some settings of TypeScript, like for example make it stricter or allow different rules, you also need to use tsconfig.json. And as you can see here are most popular properties that you can see inside tsconfig. So first of all, inside tsconfig we have a property which is called compiler options, and this is what we typically want to change. First of all is target. So what is target? This is to what JavaScript version we will transpile our TypeScript, and here we have a configuration of ECMAScript 5. The next thing is a module, and here we're specifying if we want to use CommonJS modules, like you can see here, or ECMAScript 6 modules. In CommonJS we have require and exports, and inside ECMAScript 6 modules we have imports and exports. The configuration module resolution is setting how our modules will be resolved, and typically you will write here node. And for example, this is one of the rules how you can configure your TypeScript to highlight some errors. And as you can see here, we have a setting no implicit any, and it is set to true. What does it mean? Sometimes you can write a code where you didn't define an any as a data type, but actually it is there by default because of how you wrote your code. And this option tells you when you have such case, which actually means this option is good because you will know that in this specific case you are getting here any, so you either need to specify it by hand or change your code. And the last thing that I want to mention is where tsconfig.json is lying inside typical Angular application. And here I have an Angular project, and in the root of it we have tsconfig.json and tsconfig.app.json. And actually this tsconfig.json is the main one, and this tsconfig.app.json is extending this tsconfig. This is exactly what you can see here. And this is the typical configuration that you will see inside Angular. For example, you have compile on save, and here inside compiler options, we have lots of different options. One more important point to know: if you want to override tsconfig for some child directory, you can just create in that child directory tsconfig.json file, and then it will override tsconfig in the root. Another TypeScript question that you might get is what is Elvis operator, and can we write please a common use of it? And actually, in order to demonstrate it better, I would like to create an interface. So let's say that we're defining an interface, which will be just a user interface. And for example, here we have ID, which is a string, and also a name, which is also a string. And now here we want to define a function, for example, getName. And here we're defining that we're getting a user, but we're using now here a question mark to define that we can get here undefined. And here we're defining that we're getting user interface. And back we want to get a string. Now inside here we will return user.name. And as you can see here, we're getting an error: object is possibly undefined. And this is happening because our user here can be either user interface or undefined. So the question is how we can fix this error. And this is exactly where we need to use Elvis operator. What it does, it just checks the nesting of the property without breaking the code. This code will break in the runtime, and we will get an error like cannot read name of undefined. This is the typical error of JavaScript. Inside TypeScript we can put here after user a question mark, and this is exactly the Elvis operator. So here we're saying, okay, we're not sure that user is there, but we're simply trying to get a name. The point is that we will still get an error here, where getting type string or undefined is not assignable to type string. Why is that? The point is that if we have here a name, then we're getting here a string. If we don't have here a user, then this Elvis operator can't read name, and this whole construction will return for us undefined, which is totally fine, because in this case here we can write or, not set. Which actually means if we didn't provide here a user as an argument, and we know that our user is undefined, we're trying to read here name. But as you can see, we're still getting string or undefined. This is obviously not that we want to return for get function name. This is why here we're defaulting to not set. And this is exactly the correct usage of Elvis operator. So if you have some nested properties and you're not sure that you can get them, then you simply put a question mark, and if you can't get them, you will get an undefined back. You for sure get a question like this: why any type inside TypeScript is bad? And first of all, you need to remember that TypeScript disables completely any checks inside language itself, which actually means if we will write here, for example, property foo, and we will write that the type here is any, and we're assigning here foo, we can simply write here something like console log foo.bar, and we won't get any errors. Why it is happening? Because TypeScript does not validate anything if we have any. But the main problem is here that typically people don't want to use any at all. They are using it just to fix their TypeScript problem, which actually means if the person is just a beginner, typically he will get some TypeScript error that he can't understand and can't fix fast. And in this case, he will just use any to fix his problem. And this is a bad approach, because actually your TypeScript application will become an application with the holes in it in every single place where you are using any, because there TypeScript is simply disabled and can't help you. So actually 90% of the people are using any not because they really need it, but just to fix their problem. And this is a wrong approach. You really must take your time and fix your TypeScript error in the correct way. So now the question is when you need to use any. And typically you want to use any if you don't know what data type you will get. For example, you could say that you have a function and you don't really know what will be the argument inside. Let's say here we have a function foo and we're getting here bar, and it might be that here we will get like a string, a number, an object, an array, so we can't really type it. But even in this case we have two different possibilities which are not any. First of all, you can use here generic, and we will talk about generics in one of the future videos. And secondly, you can use here unknown type that you already know. If we will write here not any but unknown, then we know that we need to check inside every single type that we are getting and understand what logic we must apply for it. Which actually means the usage of any inside any application must be super limited. And it is quite easy to understand how bad TypeScript application is. You can simply open a new project, maybe in your new job, and just try to find all usages of any. And if you see in the huge project like 2000 usages of any, this is not a safe project. But if you see like 5 or maybe 10 occurrences in the whole project, then this is totally fine and this project is safe. And you will for sure get a question regarding enums inside TypeScript. And typically it will be like this: what is an enum? Can you write an example? And why are enums so good? So first of all, the question is what is enum and how we can create one. And actually for this we are using reserved word enum and then the name of our enum. And the typical code style to write a name of the enum is with the capital letter. This is why here let's create an enum for our statuses. This is why here let's name it status enum, and we simply create here an object. Now here inside we're creating keys and values, which actually means it is really similar to the object and not to the interface. And typically we're naming our keys uppercase, but it doesn't really matter, this is just a code style. So here we can create an active key, but here we don't put a colon but equal sign, and here we're assigning active, then comma, and we have a next status enum, which is possible. And here we're writing draft, and this is a draft, and the last one here is archived, and the value is archived. So what is enum at all and why it is so powerful? First of all, as you can see, it is looking kind of similar to the interface, but actually it is not. Interface is simply a representation of the object. We just define inside all keys and the types of our values. But here it is different. We're essentially defining here constants that we can reuse everywhere, which are related to our statuses. So essentially we could write here just const and use it everywhere. The main difference is that inside TypeScript we can use enum not just like a type, but as a value. Just remember it, this is really important. Which actually means if we're creating our function, for example, is active, and we're providing inside the status, we can use here an enum as a type. So we're writing here status enum. And back we want to get a boolean because this is check for is active. But inside we can use our enum as a value. And this is super powerful. This is exactly why enum is so good. So here I can return not state but status. And here we want to return our status equals status enum dot, and here we have a nice autocomplete for active, which actually means here we're comparing the status that we got as an argument with the status enum dot active. So first of all, we know that we grouped all our possible statuses in just a single enum. And now in the whole application, we're not using just strings to compare, so we're not writing here something like active, where we can make a typo. We really use here an enum, and it is everywhere the same. Which actually means we can change this word active here, and it will be updated in the whole application. Secondly, we're using here enum as a data type, but also as a value. And now let's see if we can use isActive and just pass a string inside. So here I want to call isActive function, and as you can see we must provide inside status enum. But actually this is a string, and people might think, okay, I can throw here active as a status. But as you can see we can't, because the argument of type active and actually this is a string, is not assignable to the parameter of type status enum, which actually means in the whole application we can't write code like this. We will write it like status enum dot and here will be active. And this is really the correct code because we are not comparing some random strings inside our application. But at this moment you want for sure to say that you are getting your data from the API and then there you are getting a string. And what you need to do in order to use your data as a string with our function isActive. And let's say that you have a user with active property, which actually means you will write here user.status maybe. But actually your status is a string. In this case you can write here as, and you already know what as is, and here we're writing that this is our status enum. This is totally fine, but only if you are getting this data as a string and not using it as a string across your whole application. You might also get a question like this: how you can create a custom type inside TypeScript and when does it make sense? So the first question, how to create a custom type inside TypeScript at all. And for this we can use a reserved word which is called type. And we can name it whatever we want, for example foo, and typically we are writing it with capital letter. And here we just assign some data type, for example a string. What it does, it creates a new type foo, which we can use, and it is a type string, which actually means here I can create a property foo of type foo, and here I can simply assign word foo, which actually means this code is exactly the same like assigning here a string. This is why a lot of beginners are wondering why do we need a custom type at all if we simply take a type that already exists. It doesn't make any sense to have here a type foo if we can just write here a string. But here are two cases when you need custom types. And first of all is readability. This is the same if we are comparing just plain JavaScript objects and interfaces. We're using interfaces to describe our entities. So we're not working with the object of ID, name and age, we're working with user interface. This is much clearer for us. If in the whole application we have a lot of strings, then it becomes unreadable and unsupportable. If we will define here, for example, a type ID, and now here we create a new property or we use a property inside the interface of type ID, it is much more clearer. We know, okay, we're talking about type ID and not just some random string, which actually means the first case to create custom types is to bring clarity to your code. The second case is to write custom type if you can't use interface. And essentially you're using interfaces much more than types, because inside type you can assign just something like an interface or maybe another data type. Inside interfaces you can pack lots of stuff and reuse interface as an entity, which actually means we are using interfaces more often, but sometimes we can't use interfaces. Let's create here our favorite interface, which will be a user interface. And let's say that we have here an ID, which is a string, then name, which is a string, surname, which is a string, and last is age, which is a number. But now we just want an interface where inside we will have name and surname. And we could create a completely new interface just with these two fields. But actually there is another way to do that with usage of omit and pick. And there are two different things inside TypeScript which allow you to get some properties from the interface or remove some properties from the interface. Which actually means here we can create a new type and we can name it user full name type. And here we will use pick inside the tag, first of all the interface, in our case this is user interface, comma, and here as a string we must provide what we want to pick. In our case, for example, we might want to pick just a name, which actually means our user full name will have an object with a single field name. And actually this code you can't write with the interface, because you can extend interface, but you can't really create an interface and cut some fields from it. We're using for this pick, and this converts our interface to the type. If we need to pick here several things, we can use a pipe. So here will be pipe and maybe surname. In this case here, as you can see in our data type, we're getting name and surname. And in the same way, we can use omit. So we can create here a new type, user, post maybe, and here we want to call omit function, provide inside our user interface, and as a second argument, we want to remove ID. In this case, inside our user post, we will have an object with name, surname, and age, which actually means we either use custom types to bring clarity to our code, or we use them as a result of some type change, like for example pick or omit. The most popular question that you might get regarding TypeScript is obviously generics, just because it is a more difficult topic that is used a lot. And actually the question typically will be what are generics inside TypeScript, and can you please write an example how we are using them? And actually generics is a difficult topic, but just to start we can describe it in an easy way. If you see in the code something like array, then open and close tag, and we're providing inside a string, actually this is a usage of generic. Why is that? Because essentially we're not just using here a data type, we're using here a construction with open and close tag, where inside we're providing a data type that we want to see. Which actually means array is a generic type where inside we can provide what exactly type we need. And it makes a lot of sense because here we're defining, okay, we have an array of strings. And typically you will write it like this. So we have an array and this is string array, and here we can write, for example, foo. Also inside Angular you can see a lot the usage of observable, and there we're writing observable, then open close tag, and inside we're providing, for example, a string, which actually means we're working with the observable where inside we have a value string. And here we can provide any value that we need. For example, here will be the data type number, which means we're getting a number inside our observable. So why generics are so valuable? They allow us not to duplicate code a lot, but just create something reusable which can accept the different data type. Just imagine the previous example without generics. We're defining here array of strings, then in the next case we're defining array of numbers, then we have array of some interface. It is not reusable. In this case with generics we can reuse just a single thing for any data type. If we are talking about functions, it is looking like this. For example, we can write here get item, and we are providing here before we are calling this function something inside. For example, this is a string, and here we can provide a foo. And typically it will mean this is the data type that we need to use inside this function. For example, the first argument in this getItem function can be any data type. And we could write any there, but it is not that valuable. This is why we can create a generic function where inside we will set the data type that we can then reuse later in this function. So we're using generics to create reusable code. And now let's write a simple example to understand how generics are working. Let's create first of all a function addID, and here we're getting an object. And actually I will intentionally not provide here a data type. Now inside what we want to do, first of all, we want to generate a unique ID. This is why here I will call mathRandom and just do toString of 16. This will generate kind of unique ID. Now here I want to return the new object where we're spreading object that we got, and here we simply add an ID. What is the purpose of this function? This function simply gets object, but as you can see it is any, because we didn't provide here a data type and it is not intentionally any. Here we're generating our ID and now we're spreading the whole object and we're adding here ID. Essentially inside this function we don't care what data type we're providing inside. For us it is just important that this is an object, and if it is an object then we can spread it and add here an ID. And the typical usage of this function will be like this. For example, we're defining the user, which is an object, with name, let's say Jack. And now here we want to get our result by using our addID function where inside we're providing a user. And actually this code will work, but as you can see, first of all, our result is any, because we have no idea what is user and we don't know what we're getting back. This is why our addID function is getting object which is any and returns any. This is not a best approach. We could leverage here generics in order to have stricter typing. To do that, we can just write here before our round brackets, inside open and close tag, some big letter, and typically you are writing T. Now here, instead of just object, we can write object then colon T. What does this construction mean? This is the definition of generic for our function, which means our function now is generic function. And here we're saying, okay, in our function we must provide a data type of the object, and actually we're using this T as a data type for the value that we're providing as a first argument. And essentially you can use this T anywhere inside the function, but in this specific function we want to use it here. Now let's have a look on our data types. I'm checking here data types and it looks completely different. Why is that? Because now we don't have any at all. So here we have add function, and as you can see, this is our generic. So inside T we are providing an object with name string. TypeScript understands this code, and TypeScript sees that we provided user as a first argument here. And actually here on the top we know that this T that we're providing here is our generic T that we provided inside the function, which actually means TypeScript understands the data type for this object because this is this object. And as you can see here, we're providing inside our add function as a T this object with name string. And this is what you can see here. We have an obj variable of object with name string. And this is what we're getting back. We're getting exactly the same object with name string and an object with ID string. This is how TypeScript shows us the merge of this object and this ID. And this is what we're getting as a result. Inside we have an object of the name, which is merged with the object of ID, which actually means now it is correctly typed, and we can write here result, and now result dot brings us two properties, name and ID, which means our TypeScript here is completely valid just because we used here a generic. But we're writing code like this when TypeScript can read it by default. Sometimes it is not like this, and in this case we must provide a data type here inside. For example, we can provide here an object with name string. Why we are writing it like this? Because essentially inside we're providing a user which is an object with name string. This is exactly what we specified here. This is the data type which we need to provide for our function. And if we will provide here, for example, foo string, then we will get an error, because actually we're getting type mismatch and property foo is missing inside our user object with name string. So generics allow us to specify what data type we're providing inside. Here we're beginning our section regarding RxJS, and actually you will for sure get some questions related to it if you are going for Angular interview. And the first question that you will get here is what is RxJS, why it is so popular, what are pros and cons of RxJS, and why do we need to use it inside Angular. So here I opened an official website of RxJS, and here it is written what is this. RxJS is a library for composing asynchronous and event-based programs by using observable syntaxes. Obviously it is not super clear and it is super dry. The main idea, what is RxJS? This is a stream-based library, which actually means we can transform anything in the stream. You have, for example, click event, you can write it as a stream. You have some data, you can write them as a stream. API call is also a stream. Working with local storage can be a stream. Then you can combine the streams, filter them, map data inside. So this is quite versatile. So what are the pros and cons of using RxJS? And I already named two of them. First of all, if we can represent anything with the streams, we can work with all them together. For example, you can combine a stream of event click with the stream of getting data from the API, if you need to. And it makes your whole application reactive. Why is that? Because actually we can subscribe to our streams, and then every single time when we're getting new values from some stream, we will re-render our components. This is exactly what we're doing inside Angular. So what are cons of using RxJS? First of all, the level of entrance inside this library is much higher in comparison to just plain JavaScript. If you simply write map and filter inside JavaScript, you are totally fine. But RxJS is much more difficult. And stream programming can be difficult to grasp from the beginning. And additionally to that, RxJS is quite verbose. You will write lots of brackets, lots of different functions, combine these functions, and this is not the cleanest code in the world that I saw. And the last question here, why RxJS is so important inside Angular? The main problem is that a lot of developers, when they are starting writing Angular code, they are not using RxJS at all. They don't know it and they are avoiding it. And additionally, they are avoiding TypeScript, which makes it even worse. The main point is that Angular is heavy based on RxJS, and it doesn't make any sense to write your code without RxJS. Then your code will be more prone to errors and more verbose. So essentially, using RxJS inside Angular is not a choice. You must do that in order to write Angular code in Angular way. If you will try to write your code without RxJS, you will just fight against a framework and it won't do you any good. You might get a question regarding basic understanding how RxJS works, and here we are getting such task. You get such user interface, like you can see here on the bottom, with ID, name and age. Define a function normalize users, which gets a parameter users with $, which is an observable of user interface array, and returns back an array of names as an observable. So the first thing that you should remember inside RxJS, we're writing properties with the $ in the end. This is how we're marking variables where inside we have observables. And as you can see here, we're getting the parameter users $, which is an observable. So let's try to create this function now. We must create a function which is called normalize users, and we're getting here our users $, variable, and this is the type observable. And as you can see, I am importing observable from RxJS, and here inside we are providing user interface array. Why is that? Because here on the top you can see this is an observable of user interface array. So inside observable we must always provide some value. This is why here open close tag, and inside we are writing user interface array. And as you can see here, this is exactly the generic that we learned together in the TypeScript section. Because here inside an observable we are providing the data type, and our data type, our value inside our observable is user interface array. Now back from this function we must return an array of names also as an observable, which means here we have an observable and this is array of names. This is just array of strings. And here we must write that this is a function. And here I missed equal sign after the name of our function. So this is the correct type definition of our function. Now the question is how we can transform our data. And as you can see here, we're getting data as an observable and we're getting back an observable, which actually means we must make a transformation inside RxJS. So we're not using just plain JavaScript here, and this is exactly what a lot of beginners like to do. They simply have some stream, they write .subscribe, and then they work with plain JavaScript. This is not the best approach for Angular. So how we can solve this task? What we want to do here, we want to map our data, because we are changing the format of our data. Here inside observable we have user interface array, essentially this is array of objects, and here we have array of strings. And exactly for this inside RxJS we have a map function, but it is working differently from JavaScript. And actually this is our second question, how RxJS map differs from JavaScript map, and you will see it in a second. Here we must return, and we're writing users $, but here we're not writing map. As you can see, I don't have map, but here we're writing pipe, and this is important because all our transformations we're doing inside pipe. What is pipe? This is simply a function to combine lots of different functions which we are calling one by one. So here we can write foo, bar, buzz, and this will be 3 function transformations which must transform our stream, and they will be applied one by one. And the result of the first function is going to the second function, and from second to third, and so on. So if you are working with RxJS, you must always use pipe. Now inside we want to write map, and as you can see, map is also coming from RxJS. And now is a tricky question, what we are getting inside our map. And actually here we are getting users just like an array. And here we can do something with this array. And what I want to do is just plain JavaScript users map. Here is every single user, and we're writing here user.name in order to get an array of names. So this is how you apply a map to transform one stream to another. So if you need to transform data inside stream from one format to another, you are writing pipe map, and inside you are getting the whole value inside your stream. And this is super important, and this is the difference from JavaScript. Inside JavaScript, if we are mapping some data, we just have an array of some data, we are writing map, and we think that we will get every single element. This is how it works inside JavaScript. But here it is not working like this, because we are mapping a stream and we are getting the whole value of the stream. This is why here inside map we are not getting just a single user, we are getting the whole data, the whole array, and only then inside this map function we can just with plain JavaScript transform our data. Another RxJS question that you must know is regarding filtering of data. And as you can see here at the question, write an example of RxJS filter and tell how it differs from JavaScript filter. And as you can see here on the bottom, we have a typical user interface, so we can use it in our example. How will we write that? First of all, we must understand how filter is working inside RxJS. And this is important. Inside JavaScript, we are filtering our data. Like we have an array with 1, 2, 3, and we are writing filter. And here inside filter, we are writing some logic to filter away elements. We are not writing it like this inside RxJS. Inside RxJS, filter filters a stream, which actually means we won't get new value inside our stream if we are not fulfilling our filter. Let's say that we want to create a function get active users. And here we also, like in previous video, are getting users with $, and this is an observable. So here is observable of our user interface array. And what I want to get back is the same observable of user interface array. Why is that? Because essentially we want to get back a stream of active users. But in order to implement this, we must create a new property inside our user interface is active. And let's say it is a boolean. Now here what we can do is return users $.pipe, just like we did previously, but instead of map here we will write filter. And filter is also coming from RxJS, and inside we are getting the full access to the full value inside our stream. In our case it is array of users. What we can do here, we can check if all our users are active, which means this active property is set to true. And inside JavaScript, and here we're writing plain JavaScript, we can use a function every. So here users every, we're getting access to every single user, and we can call user.isActive. So if we have user is active true for every single element, then this whole logic will return for us true. And now the question is, what will happen if inside our filter inside RxJS we're getting true as a result? Then we will continue to work with the value of our stream, which actually means here we will get our users. So we can call it like this, get active users, and in order to simulate our users array, I will write here of. This is just a helper function from RxJS to generate streams from plain data. So here I have an array with the object ID 1, name Jake, age 30, and is active true. We can even move it outside to make it more understandable. So this is all our users, and we're saving them in this property users $. As you can see, this is an observable of our user interface. And we can write it here. This is an observable of user interface array. And now when we want to call getActiveUsers, we simply throw our stream users inside. What will we get back? For example, after this we can write .subscribe to get the result. And here active users. And now here I just want to write console log. And here we have our active users. What does it mean? When we will see this console log? Only if we could go through filters. And actually in this case here we can, just because here we have is active true. This is why inside our function we're checking every single user. We see here user is active, true, which actually means here we will come inside our subscribe and see our console log with active users. As you can see in browser, here is our response, our console log with our user ID, name, Jack, age, and is active. But if I will set our user to false and reload the page, we will never see our console log, just because our filter is never fulfilled. Which actually means we're using filter when we need to filter our stream, and then we're sure that we won't update the value inside our stream if the result of our filter is not true. You might also get a question regarding error handling inside RxJS. And as you can see here, we have two questions. First of all, create an observable and add error handling to it. And secondly, how will you write subscribe to be ready for this error? And actually here on the bottom, I already have a user interface which we can use in order to build something where we will catch an error. And actually what I want to do is just create a function where we will map data inside. But additionally to map, we will catch an error there. How it will look like? First of all, it will be similar to our function from the map video. So here we will have a function normalize users, and we're getting here our users dollar, which is an observable, and this is our observable of user interface array. And what we want to get back here is observable of strings, because these are our names and this is an array. Now inside here we will write exactly like previously pipe and map, so users.pipe. Inside we're using map function, and here we have access to our users, and we can map through our users, get access to every single user, and get the username. And actually this code will never fail, because we always have an array and we're getting map inside. But in a lot of cases, and most popular case here is HTTP request, we will want to catch an error. Because for example, if you are getting an error from the API, you need to catch it and change your observable. This is exactly what we want to do here. And actually we're not using throw, for example, like we're using in plain JavaScript. Inside RxJS we have a dedicated method to catch our errors. This is why inside pipe after our map we want to create a new function, and we want to use here a function catch error from RxJS. And here we're getting an error, and now inside we can do whatever we want. For example, here I want to write console log error, and here is our error. But as you can see here, we're getting an error. We're getting here argument of type error any void. This is exactly our error function, is not assignable to parameter of type, and here we want observable string array. And this is actually correct because our function must give back observable of string array. If some error happened inside our stream, now we have catch error, but we are not returning anything, and this is wrong, and TypeScript is saying about that. So what we want to do here, we want to return at least something, so our stream is not broken. And here I will recommend to use the function of, which, just to remind you, is helping us to convert just plain JavaScript value in the stream. And here I just want to put empty brackets, which actually means we're saying, okay, we just have an array of empty users. So as you can see, after saving, we don't have any errors, and now our code is completely valid. So we're making here map, and actually it doesn't matter if we're using here map or 10 other functions, we have here catch error, which actually means if we will get an error, then we will simply respond with an empty array. It doesn't really matter what error happened during all our transformations. So now our function normalize users is completely safe, because if we have an error, we have catch error. And every single time when you need to handle an error inside RxJS, you are using catch error function. But now as you can see, the second question, how we can subscribe and be ready for that error. For example, we want to subscribe to our stream from normalize users, but we also want to handle error correctly. And actually, in order to test this code, I want to copy it inside Angular component, so we really see how subscription works. This is why here on the top I will paste our user interface, and I will copy-paste completely normalize users function and just put it inside our constructor. Obviously we could store it in this, but it is not the matter of this video. So as you can see, we define this function inside constructor, and now we want to use it. This is why here I want to write normalize users, and here we're calling it, as you can see, with the stream. We don't have a stream, this is why here I will use auth to create a stream, and now inside we have some data. And let's create here a user with ID 1, and this is a string. Then we have here name, for example, foo, and last is age, for example, 30. So this is our data, and normalize users returns for us an observable. This is why here we typically will write .subscribe, and here we will get some response. This is why here I want to write console log response and check what we're getting in browser. As you can see, after page reload, we're getting res foo, which actually means it is working correctly and we mapped our data. But let's try to throw an error inside. This is why here inside our map, I want, instead of just returning map, make a throw. So here throw new error, and here, for example, foo. Now let's check if it works. I will reload the page, and here we're getting error foo. But actually this is just a console log that we wrote here inside catch-error. Actually we don't have any error at all, and here we're getting res empty array inside this console log. What does it mean? Actually we successfully handled error and we don't get any error inside our usage. But now let's comment out this catch-error and check if it's working. I will reload the page, and now we really see an error foo inside our app component, and we didn't handle it correctly. Which actually means if you are not using catch-error, you must handle it correctly when you are using subscribe. And in order to do that, we must write different things inside subscribe. First of all, we must provide a next function, and this is our success. This is exactly what we have now here. But we can also provide error and complete. This is why here let's provide inside an object, and the first value here will be a next function, and we're assigning here exactly this. And now here I can close this function. The second one here will be error function, and here we're getting error as an argument, and we can write inside console log error, and here is an error. So now if we have an error, we will come here in the error section. If we don't have an error, we will come inside next, which is our success. And as you can see in browser, when I'm reloading the page here, we don't have error anymore. We simply are coming and we see console log foo inside our error here. And additionally to that, you want sometimes to make something in the next and error simultaneously. And for this we have a complete method. It doesn't really matter if we have an error or we don't have an error, we will come here in the complete. And here we can just write console log complete, and we know that here we will always come and do something inside this function. So inside RxJS you have just two possibilities. You either use catch-error beforehand, and this is the correct way, or you handle your error inside subscribe. This is important to do if you can't really change your observables and handle it correctly. Inside RxJS you might get a question like this. Do you know combine latest method? Can you write an example? And if you don't know, combine latest is really popular in RxJS to combine streams, and it is highly used in Angular. So the main point that you need to remember regarding combine latest is written here is learn.rxjs.io. When any observable emits a value, emit the last emitted value from each. What does it ever mean? It means that we have several observables and we want to get a single grouped result. Every single time when any of these observables are firing some value, then we're getting results from all of them. So let's write an example how we can use it. Let's say that here inside our constructor, inside of component, we have three different streams and we want to combine them. This is why here we're using function combine latest, and inside we're providing an array. And here we can write several streams, but for the sake of better understanding, I will create it here on the top. So we have a stream foo, this is just auth of string foo. Then here I will create a stream bar, it is just auth of bar property. And now here we have buzz stream, which is auth of string buzz. And now inside our combine latest, we are providing several streams where we want to get a grouped result. So here we're providing foo as a stream, then bar as a stream, and buzz as a stream. And here after this we can subscribe to the result and check what we're getting back. So here I'm writing res, and let's look in browser. As you can see here, after page reload we're getting this single liner, result, and here we have foo, bar, buzz. What does it mean? Here we subscribed to 3 different streams, this is an array, and now here we're getting all these values as an array back. So if you need to group several streams, then combine lattice is really a good choice. But now let's look what will happen if we will change this foo, for example, to interval. And if you don't know interval inside RxJS, it simply triggers every n milliseconds. In this case here, every single second, we're triggering new value inside the stream. Let's look in browser. As you can see now, res is constantly updated, but we're not getting here some final value, we're getting here the current value of every single stream. And this is extremely important because in Angular, really often, we want to have an updated version of all our streams that we can render. And here is one more thing that is important to remember. Our combine latest does not wait for all our streams to be fulfilled, which actually means at the moment when we're getting the first response from any stream, then here we will get all values of all our streams. So in comparison to that, if you need to emit something only when all your streams are fulfilled, then you don't need combine latest, but combine all, as you can see here. But actually combine all is not that often used, this is why I don't want to focus on that. You might also get a question like this: what is behavior subject? Can you name the most common use case for behavior subject in Angular and how it differs from the subject? So the first question is, what is behavior subject? And actually this is a possibility to create a stream to which you can later subscribe, and there is also a possibility to update that stream. So let's try together the most popular example inside Angular. So here I have our app component, and let's say that we want to define new behavior subject. And let's name it users with $, and here we're writing new behavior subject. And here inside we must provide the data type of our data. And actually here we must create, for example, our user interface, so we can define what type of data we're getting from our behavior subject. So if this is a user interface, then we have, for example, an ID and our name, which is string. Now here inside our behavior subject, we can say that we're storing user interface array. Now after this we put round brackets to call new behavior subject, and inside we must provide a default value, and it will be an empty array. So once again, here we created behavior subject, and inside, as you can see as a value, because this is a generic, we have user interface array. So we're creating behavior subject with word new, we're providing our data type inside, and here with round brackets we're calling it. But additionally to that, we're providing default value as an empty array inside. What does it give us? Now here we can write users with $.subscribe just like normal observable. And here is our res, and let's check what we have inside. So res, res. As you can see in console, we're getting res empty array. Why it is happening? Because actually we set it the default value of our behavior subject, and now here, after we subscribe to it, it was emitted. What does it mean? Behavior subject on initialize always emit its default value. The next thing that we can do with behavior subject, we can change it, and this is why it is so commonly used. So what I want to write here is set timeout, just to simulate, for example, an API call. Here inside I will write 2 seconds, and now here we want to call users.next, and this is exactly the function to update our behavior subject. And inside we're providing new value. For example, we got from the API an array with object ID 1, and here name will be foo. I'm just saving this and reload the page. As you can see on initialize, our res was empty array, but after 2 seconds our res is an array with our user that we got. And typically you will use such approach together with HTTP GET. For example, you are getting an array of users from the API, and this is exactly your state inside your component. And you want to update this state after you receive the data from the API. So inside success of your HTTP GET, you will use users next and provide the data that you got there. Then your stream will be automatically re-rendered if you are rendering it inside Angular, or all your subscribers will be notified like we did here. So what is behavior subject? This is a possibility to use something like an observable, so we can write there subscribe, but also with next we can simply update the value. And additionally to that, at any moment of our time, we can get a current value from our behavior subject. So here I can write users$.getValue, and it will return for me the current value. I'm reloading the page, and as you can see, this is exactly our current value. Yes, sure, we are getting exactly the same value in our subscribe, but here we can use it synchronously in the whole component without need of the subscription. You can simply call users.getValue at any place. So we successfully answered the first and the second question. The last one is how it differs from subject. And actually we have not only behavior subject inside RxJS, we also have subject. But actually subject we're using much rarely. So here, for example, I can create subject with $, and I'm writing here new subject. We simply call it with round brackets because we are not providing anything inside. After this, we can simply write subject with $.subscribe, and here is our res. And now here let's console log subject, res. And now here inside our set timeout where we wrote users next, I want to call subject with $.next. And actually here we can provide some value, for example, let's say 1. As you can see here, we don't see the first subject like we saw here, so we don't have an initial value. First of all, because we can't provide it inside our new subject, and this is exactly the difference between behavior subject and subject. Subject is not holding an initial value. This is why after our subscribe we don't see any initial data, but only after we triggered next, like we did here, we got our value here. And additionally to that, subject does not hold value, which actually means I can't in any place of my application write subject with $getValue. This function simply does not exist, and TypeScript throws an error. This is why actually we're using much more behavior subject than subject, because it is more versatile. You might get a question like this: what is the difference between observables and promises, and what we should use in Angular? So inside plain JavaScript or frameworks like, for example, React or Vue, we're not using observables, we're using typically promises, because this is essentially what we need to do in order to work with API. We're writing something like fetch request to the API, we're getting data with then, or we catch an error later, which actually means promise is something which is happening over a long time, but at the end it only happens once. Observable is a completely different thing. This is a stream of your data, which actually means this is something where we can get new data with time, and then we can react with subscribe to this change of the data. And typically people who are coming from plain JavaScript or from React really don't want to use observables inside Angular just because they don't understand them. This is the problem, because essentially inside Angular you should almost never use promises, we're using everywhere just observables. Why is that? Because we can represent anything in our application with observable. For example, HTTP call can be an observable, our mouse move on the screen can be observable, and working with behavior subject can also be an observable, which actually means we can combine different observables from different source of data. So typically what people do to start working in Angular, they just have some observable. Like here I can create an observable foo with the function of. So here I have just an observable of value 1. And instead of using it like an observable, so foo $, and then .subscribe, and here we're getting the value, which we can, for example, console log, They are trying to work with it like a promise, and they understand, okay, we have an observable, I don't know what is an observable, but I can write here to promise, and then I'm working with something with which I'm familiar. And then they're writing here .then, and they're getting a value, and they can console log it. And essentially it will work similar, and we can check it in browser. As you can see, we're getting 1 and 1, once from the subscribe, once from promise, but the main problem is that our promise will happen only once. We will never get new data from this observable. In the observable it is working in a different way. We can update the value inside our observable stream and then subscribe to its changes, and it will happen again and again. In RxJS you can also get a question like this: what is the difference between cold observables and hot observables? And the main thing to remember is that observables are lazy. They will be never executed if you don't have a subscriber. This is why typically in Angular people are doing the problem with HTTP. They are writing this .http.get to fetch some data from some URL, and then they don't write subscribe. And this line won't do anything because observable is lazy. It will be never executed without writing subscribe here. Additionally to that, let's look on the cold and hot observables. So let's define an observable and subscribe to it twice. And in order to do that, we can just create here observable with the call of new observable. And inside we're providing a function with word observer, and here we can call it. For example, I want to call it with observer.next, and inside I'm passing a value, and in this case I want to pass inside mathRandom, which actually means every single time when we subscribe to this observable, we will provide inside a value which is mathRandom. And now here I want to subscribe to it twice, so observable.subscribe, and we're getting here some data, and we want to console log this data, and we want to do it once again. So again, this is just an observable with mathRandom inside as a single value. And here we're subscribing with 2 subscribes. Let's check this out. As you can see in browser, we're getting 2 different values. These are both mathRandom, but they are different. And this behavior is typically called unicasting, because our subscribers are not in sync. This is why these are called observables. Why is that? Because essentially this value, this mathRandom, is inside our observable. And when we have the value inside observable, then we always get called observables, because all our values will be not in sync. This is exactly why we're getting different random numbers when we have 2 subscribers, which actually means all our subscribers will always get different values. And typically this is not a problem at all, but let's look how we can fix it. And actually we must convert our cold observable to hot observable in order for all our subscribers to get the same value. And we can easily do that if we will move this mathRandom outside of our observable. So let's create here just a property random, and we assign here mathRandom, and after this we put this value inside an observable, which actually means now we're storing value outside of the observable, and it makes our observable hot. Let's check this out. I'm reloading the page and we're getting always similar results for all our subscribers. You might get such questions regarding RxJS. What is the difference between map, flat map, merge map, concat map, switch map, and exhaust map? And the main problem, if you will just jump to the Google and check every single method, you won't understand a thing, because they really work kind of similar. And to get things even worse, you can sometimes solve your problem with the usage of 2 different methods here, which actually means it is not that clear what method to use. This is why here I prepared a helper function, so you can directly see the difference between all these methods. And actually, first of all, we must start with map, because actually map here is not something that we want to compare with others. We already know what map does. We just transform our observable without subscribe. This is why here to test that we remember map, we can just write from, and here we can provide an array, for example, and we want to change every single property of it. This is why here we're writing pipe and map inside, and here we have access to every single element, and we can, for example, multiply it by 10. And after this we can simply subscribe and console log what we're getting. I will comment out all this code, we will need it in a second, just to check that you remember how map is working. I will reload the page here and we're getting 0, 10, 20, 30, 40. Why it happens? Because we have an observable, which is an array of data, and here are values which are coming one by one. And here we're mapping every single value to the new one. And with this logic, we simply change the value inside our observable without resolving it. This is why inside subscribe here we're getting these values. So we're using map to transform our observable values to another format. But now we're coming back to all these different methods that we want to compare. And here is the helper function for this. What is this function? This is just a function example where inside we will provide different operators like merge map, flat map, concat map, switch map, and so on. And this is an operator inside, and we're creating a stream. And after this we have pipe and then this operator, for example merge map. And what we're doing, we're creating a new observable and we're delaying it with 500 milliseconds. And after this we have a subscribe with success, error where we don't have anything, and console log for completed. So let's compare how it works. And first of all I have here merge map. I'm reloading the page, and as you can see, we're directly in 500 milliseconds are getting 0, 1, 2, 3, 4, and then merge map completed. So what merge map does, it creates an observable for every single value inside our stream without waiting for the last observable, but it also does not cancel the last observable. What does it mean? Here we have our from 0, which actually means our merge map directly creates an observable and resolves it. And the same is going with 1, 2, 3, 4, and we're just getting here values. So if you need to create an observable for your source element directly without waiting for the previous one, then merge map is a way to go. Additionally to that we have a flat map, and actually flat map is just an alias for merge map and it is deprecated. Let's check this out. As you can see in browser it is working in the same way. But now let's try something different, let's try concat map. I will reload the page here and we're getting 0, 1, 2, 3, 4 and then concat completed. What is more importantly, you could see there this delay 500 milliseconds. Why is that? Because concat works differently. For every single source item, it creates an observable, but it waits for the previous observable to be completed before creation, which actually means we're getting 0, here we have our delay 500, we're getting this console log, then after this we have 1, we're getting this observable with delay, we're getting console log, and so on. So when we want to use concat map is when we want to make, for example, HTTP call, which is an observable, wait for the response and make additional HTTP call. There we need concat map because in this case we are waiting for the previous observable, and this is the valid use case for it. Now let's look on the switch map. So here I will paste switch map method and let's check how it goes. I'm reloading the page and we're just getting 4 and switch map completed. Why it is happening and what is the difference? The main difference between switch map and, for example, concat map, that it cancels all previous observables, which actually means here we have 0 and we're coming here and we have here an observable with delay 500. So this observable is still there, we're coming to 1 and here we're trying to create observable, but we already have an observable and it will be cancelled, and then we're cancelling our observables 1, 2, 3, 4 and only 4th observable won't be cancelled because all observables before were cancelled and we don't have next element to cancel our 4th element. Which actually means you must use switch map when you need to cancel previous observables. And now let's look on exhaust map. So here I want to write exhaust map and let's check in browser. As you can see, we just get 0 and then exhaust map completed. Why is that? Because essentially it works completely the opposite. Here we're ignoring all our next observables when we have a running observable, which actually means we have here 0 and here we're getting our observable with delay 500 and then we're trying to create 1, 2, 3, 4, but we still have this observable with delay 500. This is why all these values are ignored and we simply get just the first value, which is 0. Now you know the difference between all these methods, but here I want to demonstrate you when you can use the different method and get the same result. As you can see here, I have an array of users just to simulate the API request. And we have here two methods, getUserById and getUserDetails. And both these methods return observable to simulate API call. And what we're doing here inside constructor, we're getting just a user, and then we're getting user details based on this user information that we got from the first request. And then we're subscribing to our details information. The main point is that here we wrote this getUser pipe, and here we're using concat map, which is totally fine. This is exactly the best usage possible, because here we want to concatenate our first observable and second observable. And when first observable completes, then we're getting here the response, and we can use it to make the second observable, and then we're subscribed to the result. As you can see in browser, we're getting foo with ID 1 and age 30. This is totally fine. But actually here I can just use switch map and it will be working in exactly the same way. I'm reloading the page and we're getting here foo with ID 1 and age 30. And this can be really confusing for you because we used different method but received the same result. The main point is that for this case, it doesn't really matter if we're using switch map or concat map. And just to remind you, switch map will complete the previous observable. But actually here we don't have previous observable because actually in Angular we're using HTTP requests just like promises. Yes, they are observables, but we just receive single time the success. Which actually means in this specific case, it doesn't really matter if we're using concat map or switch map, both will give us the same result. Another question that you can get on Angular interview is what is SPA, how it is different to server-side rendering, and what are the pros and cons of SPA. And the first question is what is SPA at all? And actually this is a single page application. What does it mean? It means that we don't have anything on the backend, but just client JavaScript. And this client JavaScript is being loaded inside client browser and is executed. And then everything is rendered on screen just with the help of JavaScript. What is the benefit of single-page application? We don't have routes like we have inside server-side, so we don't have something like /foo or /bar inside your URL. We just build the content with the help of JavaScript based on the route where we are. Which actually means our server does not do anything at all, it simply delivers an empty HTML page with injected JavaScript, and our JavaScript does this heavy loading. So what is the difference between server-side rendering or SSR and SPA or single-page application? Previously we had just server-side rendering. What does it mean? Our server rendered an HTML page and delivered it to the client. And we had routing inside backend, which actually means when we're jumping in another route, then server delivers for us another page. Inside single-page application, everything is done with JavaScript. So the main question is now what is the pros and cons of using single-page application versus server-side rendering. So the first point here, server-side rendering is easier. We simply deliver an HTML page to the client and this is it. But the main problem is that this HTML page is fully static. To make something on it, we still need JavaScript, which actually means at the end we have a mix between server-side rendering and some JavaScript which we are applying on top of it. Inside single-page application, it is different. We don't do anything on the server and we do everything on the client. We're building our state on the client, we're rendering our HTML page on the client, which means we're not mixing things and it is easier to support. Additionally to that, nowadays a lot of websites are really dynamic. For example, you have some application where you can log in, you can do some transactions maybe with your bank, and you are doing all this stuff without page reload. This is really efficient and comfortable for the user. But there are some problems here. We are doing everything on the client, which means server does not do a lot, but the client machine does a lot of heavy lifting, and it is not always efficient. Additionally to that, the page that we're loading on the backend is completely empty, because we're building the whole page by using JavaScript, which actually means it is really bad for search engine optimization, because, for example, Google Search can't really access our page and scan it to use inside Google Search, because the whole content is only applied afterwards by JavaScript. So now the question is when it is really worth it to have single page application and when we can just do server-side rendering. Actually, if you simply have some HTML or some small logic that you can fully build inside server-side without client-side, without JavaScript, or you just need like 50 lines of JavaScript, then it is a way to go. You can simply render everything with server-side and it is totally fine. But if you have difficult logic inside JavaScript, then it is much better to build it, for example, inside Angular, inside single-page application. In this case, we can work with our state, routing, our services, we can reuse everything on the client, and it is much easier. You might also get a question like this: what are the pros and cons of using Angular? And first of all, let's talk about pros. Angular out of the box delivers for us quite a lot of stuff, like for example routing, animations, words, services, and much more. Which actually means we're getting quite a lot of stuff out of the box without need of installing additional libraries. Secondly, inside Angular we are getting TypeScript by default, which actually means we are getting static typing, and this is extremely important to build safer applications. This is why Angular is a framework which is suitable to build big production applications. The next point to use Angular is that we have inside React.js, and yes, it is not an easy library, but it allows us to build our application in a reactive way. And the last point in my list is that we are getting dependency injection inside Angular. We will talk more about dependency injection in another video, but you must understand that this is something which allows us to scale our applications indefinitely, because we can define different modules and isolate stuff which belongs to this module, for example components or services, and then we just expose what we need to use outside. This is why it is extremely powerful tool to build scalable applications. Now let's talk about cons of Angular. First of all, the level of entrance is really high, because we need to learn additionally quite a lot of stuff. We have things like TypeScript, React.js, and it is really difficult to start using Angular on a good level if you don't master them. Additionally to that, we have things like dependency injections, which makes it even more difficult to start. Another problem that we have inside Angular, we have breaking changes from major version to major version. Now it is much better than at the beginning when Angular was just developed, but still you need to update quite a lot of stuff if you want to jump to higher version. And the last point, which is really difficult, the code base of Angular is extremely huge, even for advanced developer. Which actually means if you really want to dig inside Angular and understand its code on a good level, it is extremely difficult to do in comparison, for example, with React. Which brings us to the next question, how it is compared to React. And actually you can get this question quite a lot, because React is the most popular framework nowadays, and a lot of people assume if you can do Angular, you have some experience with React. And actually it is not that much to say here, because these two frameworks are completely sufficient to build large applications. Also, the level of entrance inside React is much smaller. Additionally to that, React doesn't have inside things like working with HTTP, implementing services, routing, or dependency injections. So in short, I would say that React is simply another framework which can do exactly the same what you can do with Angular. You might also get a question like this: how does Angular work from files perspective? In what file it starts loading, what files are loaded next? So here I have an Angular application, and let's look how it works from start. And the first file that we need to look at is Angular.json. And as you can see, here is our schema where we specify how our project must load itself. The main line which is interested for us is architect build, and here we have main, which is source main. This is exactly our initial file that we are loading. Let's look on it. We must jump inside source main.ts, and this is what we have in newly generated Angular application. As you can see here, we have just a single command, bootstrap module, which actually means start our application and start this module. And inside bootstrap module, we are throwing app module. This is our main module inside Angular. Let's look on this app module, which is lying inside source, app module TS. So this file is loaded next after our main TS. And the most important part here is this bootstrap line, because it means what component we must load next after our module. Additionally, to load in this component, we can register lots of different things, like for example imports here or declare our components. But most importantly is what component will be rendered as the first component inside our Angular application. And as you can see, it is an app component. Let's look on it. Here we have our app component TS inside source app, and here we don't have any code except of selector and template URL, which leads us to app component HTML, which actually means this file is what will be rendered by default. Let's look on it. Here is our app component HTML, and here we just have 2 lines. In initially generated Angular application, you will have lots of code here, which is just static markup for Angular application. I removed this static markup and just wrote here h1 tag Angular interview. Let's look in browser. This is what we see on the screen. This is the first and only component that we loaded here. Additionally to that, here we have a router outlet, which is a part of router module, but we will talk about it in the next videos. Most importantly, that you must understand, first of all, we start with our main TS, then we load our app module TS, then we load our app component TS, which includes this HTML file that you can see here, and then we have a tree of our components, which actually means if we will render here some child component later, then this will be a child component which will be rendered inside our app component. And then inside child component, we can render next component, and so on and so on. You might get a question like this: how you can share your data between 2 different components? And inside Angular, we have 4 typical ways to share data between components. First of all, let's look on parent-child communication. As you can see here inside source app, we have our app component TS, but we don't have any other component. I want to copy-paste it fully and just create here child component TS to show how these 2 components can communicate. So we are pasting everything here and just changing our selector to app child, for example. Here is our template URL child, component HTML, and we don't need any styles. Now let's create here child.component.html and render here some text. For example, I'm a child component. The last step that we should not forget, we must register this child component TS inside our app module. This is why we're adding inside our declarations child component. Now we can jump inside our app component HTML, and here, for example, under h1, we're rendering our app child component. And actually here inside child component TS, I forgot to change the name. It should be child component. As you can see in browser, we successfully rendered our child component inside our parent component. Now the question is how we can give data from our parent component inside our child. And in order to do that, we must define some data inside our app component. For example, let's say that we must give current page to our child, and here we're defining that it equals 1. In order to do that, we must jump inside child component TS and define our input. So we're using inputs when we want to provide some data inside a component. And this is exactly how our parent can give some data to its child. So here we're defining it with add input, round brackets, and after this we will have current page, and we want to define that this is a number. But as you can see here, we're getting an error that maybe current page was not provided. This is why here we must put a question mark, because it will be either undefined if we didn't provide it inside component, or we will get number. Now we must jump inside our app component HTML, and here inside our app child we can provide this value current page. And here we're providing the value from our component, which is a current page. And the last step that we need to do inside our child component, we must jump inside HTML file and render here our current page. Let's check if it's working. As you can see in browser, we're getting I'm a child component 1, and this 1 is exactly the value from the parent. So how we are doing that? With this attribute inside square brackets, which is exactly an input, we are providing a value from our parent to the child. And now inside child we can render this property. But now we have completely different situation. Let's say that we want to provide a value from our child to the parent. How we can do that? Let's say that inside our child component HTML we have a button. For example, here I will render a button, and here will be go to parent. And inside our child component, in order to provide a value to the parent, we must define output. So we're using outputs in order to deliver our value to the parent. Let's name it, for example, notify parent. And in order to create it, we're using equal sign and we're writing here new event emitter and we're importing it from Angular. So now what we can do, we can call this notify parent when we're clicking on the button. So here inside our child component HTML, we have our click function. And here what we want to do, we want to call notify parent.emit. And just to remind you, here we are not calling notify parent, this is not a function. We have a special emit function inside our notify parent. But now we must tune our code inside parent because our parent doesn't know anything regarding notify parent function. This is why here we must jump inside our app component HTML, and here we know, okay, we are getting event notify parent. This is why here are round brackets, and here we want to call a function notify parent, which is a function inside our parent component. So this is why here inside our app component TS we must create a function notify parent, and here it will return void, and we just want to console log here notify parent. Let's check in browser. We have here a button, go to parent. I am clicking on it and we're getting console log notify parent inside parent. And at this point you for sure want to say, okay, but we didn't pass any data. Yes, sure, this is why inside our click, inside child, we can provide here some data. For example, number 333, it can be any value or property from our component. Now what we are doing here inside child component, we are defining that we are providing inside a value and it will be a number. And this is exactly the generic that we learned inside TypeScript section of the course. Now we must go inside our app component HTML, and here we want to pass $event inside our notify parent function. And this is exactly how we are getting data from our child. And it is always called $event. Now we must jump inside our app component TS, and here we are getting the value, which is our data from the child. And we know that this is a number, and we want to console log it here. So here let's just check what is inside value. We're looking inside browser, I'm clicking go to parent, and here is notify parent 333. This is exactly how we are passing data from our children to our parent. Another way that we can use is creating a service. When do we need to use a service? If we have a deeply nested components, then it makes a lot of sense to use service because it stays outside of our tree of components, which actually means if we have here a component appchild, then appchild 2, 3, 4, we have deep nesting, and it is difficult to pass all these events and all these values. This is why it is much easier to create a service and share this service with all our components. How we can do that? In order to do that, I will create here a service. Let's name it shareable service TS. And here to define a service, we're using $injectable, and don't forget round brackets. And here we're exporting our class, which will be shareable service. Now inside class, we can create any values, any functions, but just to show you how services are working, we can simply define here a property, for example, current page. And I'm setting our current page to 1. Now we must register our shareable service inside a module. So inside our app module, we must create an attribute here which will be providers, and here inside we must define our shareable service, which actually means we always must register our components inside declarations and our services inside providers. And now we can jump directly to any component and use this service. For example, inside app component, we can, with the help of constructor, inject this service here. And we're using such notation: private, then shareable service, and here will be our shareable service. Now here directly inside constructor, I want to try and use it. So here I will write app component, and here I want to call this dot shareable service dot, and as you can see, we have access to this property current page. Now I can copy paste this code and throw it inside child component test. And it doesn't really matter in what component I will throw it, we can use the shareable service and our nesting doesn't matter. But the only thing that we need to change here is write child. Let's check this in browser. I will reload the page and we're getting app component 1 and child 1, which actually means both these components have access to our service and they can reuse values or functions from this service anywhere. And the last thing how you can share data between all your components inside Angular is by using some additional library which is working outside of Angular. And typically these libraries are calling state management, and the most popular library here is excersises. And we will talk about this library later in the course, but you must know that this library is a wrapper around Redux. So Redux is the most popular state management for any framework, and excersises is an implementation of Redux inside Angular. So if you need something super scalable for a big production application, you typically need to get excersises in order to have a strict way to do things inside your application. So to sum this up, we have 4 ways to share data between our components. First of all, from parent to child, with usage of input. Secondly, from child to parent, with usage of outputs. Third is our services, which are global and are available for all our components. And the last one is complete state management library, like for example, excersises. You might get a question like this: what ways of binding data exist in Angular? Write examples. And actually inside Angular we have 2 ways of binding. We have one-way binding, which means in one direction, and two-way binding, which means in both directions. And typically we are writing our code like this. As you can see, I have an empty app component, and here is my HTML file. So here we can write, for example, input, type text, value, with square brackets. And here inside we can provide some initial value. For example, let's name our property initial value. Now inside our TS file here we can just create a property which will be initial value, and let's write inside a string initial value. As you can see in browser, we have an input where we have predefined text initial value. Why it is happening? Because we have one-way binding. And this happens because we're using this attribute value with square brackets, and we're getting this value from our component, which actually means every single time when this initial value inside our component changes, then the value inside our DOM element re-renders. But how we can implement the change of this value inside our component when we interact with DOM? And for this we can add here an event keyUp, and let's name it change value. And here inside we must provide our $event. Now here we can create a function change value, and we're getting here our event of type event, and here it is a void function. And now inside I just want to console log our event. As you can see in browser, every single time when we have a keyUp event, we're getting here our keyboard event, and we can use it, which actually means we can directly change our initial value. And actually the name initial value then is not that good, because this is just our value for the input. So let's rename it to value, and now here we're getting our value. And now what we want to do here, we want to assign inside our value the value from event target value. And as you can see, we're getting here an error cannot find name value because event target can be null. This is why here we must wrap event target and write as HTML input element. In this case here we're reading our value correctly and we can assign it so this value equals value. Now let's try to render exactly this value inside our HTML after our input. So here is our value. You can see it inside browser. This is initial value. And now we're changing it and it is directly changed inside our component and re-rendered. So actually we created here two-way data binding because we have one way where we're changing our component and directly our DOM is changed, and secondly we have a key up event where we're changing directly our component value from the DOM. And this is exactly how typically people are using inputs inside Angular. But there is another possibility. We're getting two-way data binding or ng model directly from the Angular, but it is rarely used, but obviously you must know it. So here we can write input, and now here we have square brackets, then round brackets, and inside we're writing ng model, and here equals and the value. In our case, it will be value. I'm just saving this and let's check this out. As you can see here, we're getting an error cannot bind to ng model since it is not a known property of input. And it is happening because in order to use two-way data binding and ng model, you must import forms inside your module. This is why we must jump inside app module TS, and inside our imports here, we can add our forms. So here is forms module, and after this we won't get such error. As you can see here, this is the input with ng model. We're getting here initial value, we're changing it directly and it works out of the box without need to specify a key up event. And actually you must understand that this notation is just a sugar for another notation. Actually we can write here ng model in square brackets, and here we have our value, and after this we can write ng model change, and here will be our function. For example, model change, and inside we're providing $event. But now we must create this model change inside our TS file, and we know that here we're getting new value, which is a string, and now here we can simply reassign this value inside value. Let's check this out. We're getting here the third input. Here is our initial value, and we can directly change it, which actually means we have several ways of binding data inside Angular. First of all, just with value, when we're reading some attribute from the component, and then we have some event to update the value inside component, for example, key up or click. Another way is to use ng model. We're using it not that often. And ng model is actually a wrapper for ng model attribute and ng model change event. You might get a question, what is HTML in Angular? And actually here you should not answer HTML, because it is not. What you see here, and this is the code from the previous video, this is not HTML. Yes, it looks like HTML and the file extension is HTML, but actually it is not. You can see it is not valid HTML. We have here things like square brackets, round brackets, then square and round brackets. This is not a valid HTML. This is a special Angular syntax, which is just Angular template, which actually means Angular template and HTML are made similar to look like HTML, but actually it is much more. So Angular parses every single template file and transforms it to the function, which actually means this or even HTML parts which are readable are not being used by Angular as HTML. Everything here is transformed in the functions, and then these functions are executed to build a DOM. You might get a question like this: what are services inside Angular? Write a date service with methods getTomorrow, getYesterday, and getToday. And actually we already created a shareable service in one of the previous videos, because we used service to share data between our components. And this is exactly when we're using services inside Angular. If you really need to share some data or store this data in some place outside of your component, then service is a nice place for it. And as you can see here, we must create date service with such methods, which essentially means we're just creating some isolated thing which has some methods which are related to this thing inside. And it makes a lot of sense because we're grouping all our methods which are working with dates inside date service. So let's create in our source app a new file which will be dates.service.ts, and inside first of all we must write injectable. And it is important because if you will forget to write injectable, your service won't be registered properly inside Angular. And additionally to that, it is important that you are not forgetting round brackets. In other case, it won't work also. So what we want here, we want to export our new class, which is dates service. And now inside we must implement three methods: get today, get tomorrow, and get yesterday. We can already define them. So let's first define get today. And inside our task, we didn't get what we're getting back, which means we must specify it nicely. And from my point of view, here we must return a date because we're talking about get today. This is why here let's write just a day. And now let's think how we can implement get today method. Actually, we could just use new date, but typically in get today method you want to get midnight time. This is why here I would write something like this: start of date, this is timestamp, so this is just a number, and here we're writing new date, and after this set hours. And inside set hours we can say 0, 0, 0, 0, and it will be midnight. Now after this we can simply return new date, and we're throwing inside our start of date timestamp. And as you can see, this is completely valid because we returned here our date. Now let's do the same for tomorrow. So here is get tomorrow, and we know we must get back our date. So first of all we want to get here today, and we already have a function for that. This is why here this get today, and we're getting inside our today property, as you can see, a date. After this we can simply return new date, and we are throwing inside our today, but we want additionally to set date. And inside set date we want to just provide a number which is bigger by 1, which means here today dot get date, this is today date plus 1. So as you can see here, today.getDate gets day of the month using local time, which means here we can just set +1, and here we're using setDate and we're getting tomorrow. And exactly in the same way we can implement yesterday. So here is get yesterday, and we're returning here date, we're getting here today, and now instead of +1 we can do -1. And now it is time to register this service. This is why we must jump inside our app module and register it inside providers. And it is important, without registration of our service, nothing will work. This is why here we are writing our date service, and now let's try to use it inside our app component. In order to do that, we must inject this service inside our constructor, and we are using for this such construction: private, here is any name, for example dates service, and here what we want to inject, this is dates service. And now inside our constructor we can console log what we are getting. Here is this.dateService.getToday, then this.dateService.getTomorrow, and this.dateService.getYesterday. Let's check in browser. I'm reloading the page here, and as you can see we're getting 3 dates. So this is exactly a date format, and here we have January 4th, this is correct, and here we have midnight. After this we have January 5th, also midnight, and January 3rd, this is all correct, and our service is working correctly, and we can reuse it anywhere in any component where we need to. You for sure will get a question regarding HTTP or API requests. As you can see here we have a question, you have an interface, user interface, with ID, name and age. Create a user service and get users method inside, which makes a get request to HTTP localhost 3004/users and returns a user stream. Write the code to get this data in the component. And actually this is the most typical use case of HTTP that you can imagine. But in order to implement this code, we must have a running API, and there is a nice library which can help us to set up it in a matter of seconds. For this, I will create in the root of my project new file db.json, and this is a JSON file which will be our mock database. So here I will define a property users, and this is an array, and inside we have our objects. And as you saw there, we have an ID, for example 1, then we have our name, John, and we have age, let's say 30. Now I will copy paste this 2 times, so we have at least 3 users. Here we will have ID 2 and maybe Jack, age 25, and ID 3, and name Mike, and age 27. Now the question is how we can start our database, and in order to do that you must install globally one package. So npm install -g, so globally JSON server. And after installation you can write inside console JSON server --watch, and here is the name of our file, so I'm starting it inside root folder of my project, and this is the port 3004. I'm hitting enter, and as you can see here is our new request, which will be created based on our db.json file. So I can open this URL localhost 3004/users, and this is the array of our users that we want to fetch. And now we can jump to our implementation. So first of all I want to create an interface for our user. This is exactly what we had inside our task. Here we have user interface, and this is what we are getting inside getUsers method. So here let's create user.interface.ts and define an interface inside. So export interface, and we have our user interface, and inside we have first of all ID, which is a string, secondly name string, and age is a number. And with this interface, it is much easier to define correctly what we are getting back. The next step that we are doing is creating our service. So here I will define users.service.ts, and inside let's create our service. So here as always we have injectable, and we are exporting here our class users service. And now inside we must define just a single method, getUsers. And as you can see here inside the task, this getUsers method must make a GET request to localhost 3004/users, and it returns a user stream. And it is important because it means that back we want to get an observable of users array. So here directly I will write that we are getting back an observable of user interface array. And this is exactly what you typically have inside your services. We don't have their subscriptions or something, we just have our methods where inside we have HTTP calls, and these methods doesn't do anything until we are calling them, which actually means here we want to return the GET request to that URL. And in order to do that, we must define here a constructor, and we want to get inside an HTTP. And if you don't know, HTTP is a package inside Angular which allow us to do API calls. This is by here HTTP client, which we are getting from Angular common HTTP, which means we don't need to install anything additionally. Now here inside our getUsers we can return this .http.get because we want to make a GET request, and inside we are providing our URL http localhost 3004/users. But as you can see, we are getting directly an error. Type observable object is not assignable to type observable user interface array. Why is that? Because actually by default HTTP GET is returning for us an object, and it is not specified what we are getting back because HTTP GET can't know what we are getting. But here we define that our method must return an observable of user interface array. This is why we must define that our HTTP GET is returning back for us an array of user interface. And for this we can open here brackets and write inside user interface array. In this case we defined correctly for HTTP GET what we are getting back. And this is exactly how you type correctly your responses from HTTP. And the last thing that we must do, we must write the code to get our data in the component. But before we will do that, we must register our user service inside our app module TS. So here we're adding our providers and we're registering here our user service. Now we can jump directly inside app component TS, and here inside constructor we must inject our user service. So private users service, and this is our users service. And now here we can write implements on init and define ng on init method. So here we have ng on init, and when our app component is initialized, we want to fetch this data. So here we will write this dot user service dot, here is our method getUsers, and we're getting back an observable, which actually means to get data we must subscribe to this data. And here back we're getting our users, and we can simply console log our users and see that they are available inside our component. Let's look in browser. We are getting an error, no provider for HTTP client. And here we see that our user service used HTTP client and we don't have a provider. Why it is happening? Because inside our app module, we must import HTTP module. This is why here I'm writing HTTP client module. And this is exactly what we need to inject in order to use HTTP inside our services and components. Let's reload the page. As you can see, we don't have an error, and here we see our response with users, which is the array of these three users that we defined inside the API. And here inside our network, you can see that we are getting request from localhost 3004/users, and this is our response, which means we successfully fetched data from the API and got them inside our component. The question that I hear most of the time in Angular interviews is how dependency injection is working inside Angular. And this is happening because we don't have dependency injection in other frameworks or in plain JavaScript. For example, inside React or Vue, we simply have imports and exports from ECMAScript 6, but we don't have dependency injections. This is why inside frontend world it is just related to Angular framework. And actually we already used a little bit dependency injection. What does it mean? We are defining what dependencies we have inside our module, what is isolated inside, and what we can use outside. As you can see here, this is our app module from the previous video. And actually this is our main module where we are defining, for example, all our components that we are using or all our other modules that we want to use. Or additionally, we are registering our services also inside a module, which actually means we can define a module and define what belongs to this module, and then different modules can import one another and use different things from different modules. So what dependency injection does for us, it lets us to isolate and define what we can use outside. And in order to understand it better, let's create users module. So here I want to create a new folder which is called users, and inside we are creating users.module.ts. And here on the right I will open our app module so we can look a little bit there and copy paste stuff. So typically you will export a class which will be users module here, and on the top we are using decorator ng module. Now inside our ng module we are defining everything that we have inside this module. For example, here we have our user interface and user service, which are really not related to our app module, they are more related to our users module. This is why I want to move this to files inside our users folder. And now actually it doesn't make a lot of sense to register our user service inside app module. We can completely remove it from here and then register inside our users module. And in order to do that, we can define providers and register here our user service. But it becomes more interesting when we are talking about components. If, for example, here we are creating components folder inside our users module, and here, for example, we have a component users. And now here I want to define users.component.ts file and also users.component.html file. Now inside HTML I will simply render users. We are now not interested in our markup, but inside component I want to export our new class users component, and on the top we must use component decorator in order to register a component. And here is our selector, for example users, and here is our template URL which refers to our users component HTML. But now we must register our component, and we're not doing it inside our app module like we did previously, we're doing it inside our users module. So here we're using declarations property, and this is an array, and now inside we can define users component. If we're not registering users component somewhere, we can't use it. But actually when we're declaring users component just inside users module, it means that we can use it only inside this module. We can't use it outside. And in order to prove that, I will jump inside app component HTML and try to use here our users component. So I'm just rendering this component and I will reload the page. As you can see here, we actually have a problem that we're trying to get user service, but it is not there. And this is our app component. And you might ask, okay, we want to use service from users module. Can we do that? Yes, sure. But in order to do that, we must provide here correct import. This is why here I am importing user service from users user service. And here we're using it. Let's reload our file again. And as you can see, we're getting users is not a known element, because essentially we used it inside app component HTML and nobody knows what is users. And here you might say, okay, but we must import users module inside app module TS. And you are totally right. In order to use our users module inside other module, for example, app module, we must register it here. This is why here we are registering users module, and now it must be available for us. And actually when we're writing this, it means that the service and all components will be available for us. I will reload the page and we're still getting an error that users is not a known element. And this is exactly why dependency injection is so important. If we are looking inside our users module, here we have a declaration of users component, but we didn't define if we can use users component outside or not. And in order to do that, we're using exports property. And this is an array where we're defining components that we can use outside. If we didn't define a component from this module inside exports, we can't use it outside. And as you can see here, we don't have any errors, and here we rendered users just because of these exports, which actually means we're using modules for dependency injection. So we're structuring everything with the help of modules, and these are our building blocks. Additionally to that, inside our modules, we're registering service and components, and they're completely isolated there. If we want to use them outside, we must import a module, not just some component or service, but a module inside the module where we want to use them. You might also get a question regarding routing. As you can see here, we have 4 questions. How to add routing to Angular application? When global routing is bad? What is React outlet? And how to create router link? Let's try to answer all these questions. And actually here inside our initial application inside source app, we already have app routing module TS. It is generated for us by Angular. And what we can see here is almost nothing. We simply have routes and we have them inside our imports with router module for root. And it is important that you remember that here we have for root because these are our global routes for the whole application. So here we isolated our routes inside app routing module, and now inside app module TS we have this app routing module. Essentially these are just 2 lines of code, and we could write them directly here, but this is the Angular structure. Additionally to that, as you can see here, we have our users module from the previous lecture. And here we have components, for example, users components. Let's render this user component by using global routes. How we can do that? We can, inside our array here, just create an object. And here we have our path, and we can put, for example, here an empty string. It means that we want to render this component in our home page. And secondly, we're providing here a component. And what we want to render here is our users component. And as you can see here on the top, we're getting full path to our users component. So the main point is that we're getting our app module, and we can use users component because we injected here our users module, which actually means now on our home page, we will render our users component. Let's check this out. As you can see here, we're getting users 2 times, and we're on the home page. Why it is happening? And this brings us to the second question, which was what is router outlet? And as you can see here inside our app component HTML, we first of all rendered our users component, and secondly we have here router outlet. And as you can understand, here we have users twice, because first of all we directly rendered here a component users, and secondly we rendered this component through the router, which actually means typically we don't render, for example, users component just like this. We simply have some layout, like for example H1 Angular interview, and here we have our router outlet. So what is this? This is a special component from router which helps us to render the components inside router, which actually means here our app component HTML is rendered, but based on our route that we defined here inside our routes on the right, we will render a component here, which actually means when we're defining here the route with path /foo and for example foo component, and then we're jumping here on /foo route, then here we won't render users component but foo component. So you already know how we can globally define our routes like this, and why we need router outlet, because if we will remove this component, then our router component won't be rendered. Our other questions were when global routing is bad and how we can create router link. And actually we can just create router link in a matter of seconds. This is why let's solve that one. So in order to create router link, we can simply write a href, but we're not writing href inside Angular, we're writing a and then router link, and here we just provide a URL that we want to use, for example /, and it will be our router link, which will jump to home. As you can see in browser, we're getting our home link, and this link is going to the home page. The main point, as you can see here, this is not just a href link, this is a special Angular link which is using HTML5 routing, which actually means when we're using this link, we will jump between routes without page reload. This is the whole goal of routing inside front-end single-page application. And additionally to that, sometimes you want to create router link differently, and you can provide here as a value not a string but an array, which actually means here we can concatenate our array. For example, here we have /, then foo, and here we have bar. The main point is that sometimes you have variables and you want to put them separately. For example, you have here /, then some variable, and then maybe bar. And the last question that we must answer is why global routing is bad. And actually it is not bad always, but you must consider if you really want global routing. And typically you don't. Why that? Because essentially inside our app routing, we will write components from different modules. And you could have here like 20 or 30 different components. And you're accessing components which are lying in different modules just directly inside your app routing. Which essentially means if we want to remove one module, for example users module, then we also need additionally to jump to routing and clean it, because essentially we're defining our routing outside of our module, and this is not the best approach. Much better approach would be to keep global routing empty, and then we don't need this import. What we can do instead, inside our users module, we can define our routes. So here I can say that we have routes, and this is our routes, and this is an array which are just routes for this module. And here we're defining exactly the same. We have here our path, which will be /, and we have here our component, which will be users component. And now here inside imports, we must define our routes. So here we're writing router module, but not for root like we did previously, but for child, because these are routes for our specific module. And as you can see here inside, we're providing our routes, which actually means in this specific case, we're defining our routes inside the module and not globally. And they are completely isolated inside this module. And first of all, in this case, it does not matter if you exported users component or not, because routes are inside. And secondly, they are completely isolated. And if we remove this users module, everything will be removed at once. Let's check if it's still working. We don't have anything inside our app routing, but I'm reloading the page and actually we're getting an error, invalid configuration of route /. Sure, for homepage it should be just an empty string. As you can see here, everything is working like previously. We have our users, and this is a component which is rendered on the home page. But now we have these routes inside this user module, which is completely isolated, and we don't have global routes. And actually in the big production applications where you have like hundreds of different modules, you almost never will see global routes, because it is much better to hide all your routes splitting by different modules. In the interview you will for sure get a question what are lifecycle hooks inside Angular and when they are called. And actually inside Angular every single component has a life cycle. These are different phases of existing of our component between creation and destroying. And Angular provides for us some lifecycle hooks so we can write our own code when these phases are happening. There are a lot of different lifecycle hooks, but these are 4 that you need mostly. And the first lifecycle hook is ng on init. And here it returns void. And typically we're using this lifecycle hook after initializing of our component. And additionally to that, typically we're writing here implements on init. It is not mandatory and you can write in your component ng on init function without implements, but it is much better because in this case you are saying that your component must define ng on init function. So what we're writing inside of ng on init? Typically we're writing there all stuff that we want to do on initialize, like for example fetching data from our API. The second lifecycle hook here is ng on changes. And this lifecycle hook happens when our props, so our inputs, were changed inside component. And it is important to remember that the first trigger of ng on changes happens previously to ng on init, which actually means you will see ng on changes the first time before ng on init. And then every single time when one of your inputs is changing, you will get inside ng on changes hook. Then you have ng on destroy. And as you can get from the name, it is a lifecycle hook when our component is destroyed. And you might question, okay, why do we need such hook? Typically you have at least some subscription inside your component and you must unsubscribe from that subscription, and typically you will do it inside on destroy. And we will talk about subscriptions and unsubscribe in the later videos, so stay tuned. And the last one here in the list is ng after view init. And this lifecycle hook happens when our component and all its children are being rendered. When do we need to use such hook? If, for example, you have some DOM element and you want to access it, but it was not rendered yet, it will happen if you will write your code inside ng on init, because at this moment your DOM is not finished with the rendering. But if you really want to get that element, you want to move your code from ng on init in ng after view init. It will happen when your DOM is fully ready, and then you can access any element inside your DOM. You might get a question like this: write an example of view child and view children. And actually you must know that view child and view children is a possibility to access our children components and children DOM elements. So sometimes we don't really want to communicate with them using inputs and outputs, but we just want either to directly call some method or change a value of our child component, or we want to access and change our DOM element. So let's try here all cases that you need to know. As you can see here, I have a component and it is completely empty, and inside HTML I have child component. And here I have child markup. This is just a variable count, but I also have TS file with several things. First of all, here is our counter 0, and we have two functions, increment and decrement, and we are increasing and decreasing our count property. The main point is that here we don't have any input, and the question is how we can manage this component from the parent. And it is important to understand that it is much better to always use inputs and outputs when possible. But in the case when you have some child component that you can't really change, you might use viewChild or viewChildren. And in order to do that, we must jump inside our app component TS, and now here we want to access our child component. And in order to do that, we are writing viewChild, and here as a first parameter we are providing child component. So as you can see, this is not just a string, this is a complete reference and import that we want to use. After this, as a second parameter, we are providing an object, and we are writing here static true. After this construction, we are writing child with question mark equal child component. So what does it mean? Here we are saying, okay, we want to access our child component through viewChild, and we are using here an option static. And this option means that we always have this element inside our HTML. And actually here you can see that this element is rendered always. We never have here some if condition, so we don't need to check that. So in this case here, Angular won't do the check for existing of this element. And here is the child, and obviously it cannot be there always. On initialize before our DOM is there, this component will be undefined. This is why we have here a question mark, and here we are writing the data type of it is child component. Now here let's say that we want to create a button, and when we click on this button we want to increment a value inside our child. In order to do that, we can create a button inside our markup and just write here that we have a click event. And here we will have a function increment, and let's inside write increment child. And now here we must create this method increment inside our app component. So here is this method, it returns void, but now here we want to access our child, so we're writing this dot child. As you can see, it can be undefined. Here we're writing dot and we don't get anything because it can be undefined. This is by question mark dot because we're not sure that this component is there, and here we want to call increment function. Let's try if it works. I will reload the page. Here is our counter, this is the child component, and here is our increment child button. I am clicking here, and as you can see, we're directly changing our child component. How it is happening? We have full access to our child component, and we can call methods from our child or read values if we need to do that. Another possible variant how you want to use viewChild is when you want to access a DOM element. And in order to do that, you must jump inside your HTML, and on any element you can write hash. For example, here we can write hash and then button. And it means that we want to access this button by this hash string. Let's try this out. I'm jumping inside app component, and here add viewChild, and inside we are not providing a component but just a string. In our case it will be button, and this is this unique hash that we wrote here. So again, here we are sure that this DOM element is there. This is why here will be static true. And here we are saying, okay, this is button reference, and this is not always there, and actually this is of type element ref. And we know that this is HTML button element. Now here we can write implements after view init. And just to remind you, we need after view init if we want to access our DOM, and we want to be sure that our DOM is already there. This is why here we're creating ng after view init, and we can do now here this dot button ref. As you can see, it can be undefined. This is by question mark dot native element dot, and we have here inner HTML. And we can simply try and assign here full. As you can see here, we're getting an error that left-hand side may not have an optional property, which actually means we must move this code inside if. So here we can write if we have this native element, then we want to set in HTML. Let's check if it's working. I'm reloading the page, and we can directly see here that our button text is changed with full. How it is happening? We have full access to our DOM node by this element ref. And actually here inside we can just console log this dot button ref and check what we are getting. As you can see here inside, we have native element, and this is exactly DOM element, and we can do with it whatever we want. Now let's talk about viewChildren, and this is exactly the same like viewChild, but for the list of data. So we can access the list of our children, and we can access the list of our DOM elements. So what I want to do now here inside our HTML, I want to copy-paste child 3 times, and I want to copy-paste this button 3 times. And now we will try to access them like a list. And in order to do that, we can write here at viewChildren, and here inside we're providing our child component, and here we're writing that this is children property, it can be undefined, and this is a query list. So this is not a single element, this is a list of child component. And exactly the same we're doing with our buttons. So here we're providing button inside viewChildren, we're getting access to our buttons reference with question mark, and this is a query list of our element ref, and here we are providing our HTML button element, which actually means for viewChildren you are always using query list and you are providing your type inside. Let's check this out. In order to do that, inside our ng after viewInit, we can access them, for example, with the loop. So here I want to write this .children with question mark, then for each, so we're accessing every single element. Here is our child, and we will simply console log this child. And now we are doing exactly the same but with buttons ref. So here will be buttons ref for each. We have access to every single button, and here is console log for this button. Let's check in browser what we are getting. I'm reloading the page, and here we have 6 different elements. First of all, here child component, child component, child component, and here are our elements ref. So this is exactly how you're accessing the list of our viewChildren or the single element with usage of viewChild. You can also get a question like this: what is the difference between constructor and ng-on-init method inside Angular, and which one we should use? So just to be clear, here we have a component, and inside we can write implements on init, but also we can just use here a constructor. So here I'm writing constructor, and inside let's just write console log constructor. And after this I'm creating ng-on-init, and I'm writing here console log ng-on-init. If we are looking inside console, we can see constructor is being called and ng-on-init is being called, because our app component is rendered. And yes, constructor is being called earlier than ng-on-init, but they both were called on initialize of our component. But here is an important knowledge. We are writing Angular with the help of classes, which actually means app component is a class from plain JavaScript. Obviously, it is not a plain JavaScript, this is an ECMAScript 6 classes, which are then being transpiled in prototypes. But actually, the most importantly, inside classes we have constructor, which actually means this constructor is not coming from the Angular, this is the default thing of classes. And yes, we can write constructors inside classes and they are working. But additionally, inside Angular we are getting ng-on-init method, and you already know from previous videos that this method is one of lifecycle methods, and it happens just right after first ng-on change, and it is being used as a live hook when our component is initialized. But inside Angular we have some guidelines. They are suggesting that we are using constructor just to inject things inside our component, which actually means here we will write something like private HTTP, and here we are using HTTP client, or maybe here private some service, and here we are injecting some service. They recommend us not to write anything inside constructor, but use for this ng-on-init. But essentially you could write here something, for example, inside this, like this foo equals 1, and it will work, and this code will be still valid, and you still can use it in production. But obviously it is better to use the recommendation and use for all your things that you want to do on initialize ng-on-init. This is exactly a lifecycle method for this. Additionally to that, I saw that some people are writing initialization of properties inside constructor and not on the top. And actually there is no difference of writing this. You can write here that you have a variable current page, and you can say that this is a number, and you can assign here first page. And actually, if we are removing here 1, then we are getting an error, property current page has no initializer. And some people would write it inside constructor like this current page equals 1. Actually, this code is totally valid, but you could just move this code here in the definition and make your constructor empty. And exactly the same you can do with your streams. For example, you have a stream current user, and this is an observable. So here you can directly assign simply this, maybe some service like current user service that you will inject here, dot, and here is the reference to current user. You can directly do it here and not in the constructor. But even if you will do it in the constructor, this is fine, this is a valid code, it is just not recommended. So in 99% of your cases, you want to use ng on init and you want to use constructor just to inject things inside your component. One of the most important questions in Angular are regarding memory leaks. And here it is, what is unsubscribe, why it is important, what are the ways. Or you can get here a question how you can prevent memory leaks inside Angular. As you can see here, I rendered two routes, home page and users page that we created previously when we created a module. And actually what I want to do now, I want to jump inside our users component ES and create here a stream of data. And here I want to create a property data with $, because this is an observable. And here I just want to use interval function inside RxJS, and here is 1000. Which actually means here we will update the value inside our observable. Now let's add here implements on init. And inside our ng on init, what I want to do, I want to subscribe to this data. So here I'm writing subscribe, I have access to the data, and now I just want to console log this data. Let's check if it's working. I'm reloading the page. As you can see, we're inside users page, and this is why inside console I'm getting data 1, 2, 3, 4, and so on. But here is the problem now. I'm jumping inside our home page, and as you can see, nothing changed. We are still getting this console logs of data, which actually means we subscribed to the stream inside users component, and we never unsubscribed from this stream, which actually means this stream is hanging there until the end of the world. And as you can see here, this is a potential memory leak. Why is that? Because we have something inside our application which is generated even again and again every single time when we are jumping to users page, and we indefinitely have these hanging subscriptions. Which actually means we must fix this because this is not good for a real application. How we can do that? There are lots of different ways to unsubscribe from your stream, and the most typical way is by creating a subscription. So what we can create here is data subscription property, and this is of type subscription. And actually here is question mark because by default it will be undefined. And now here inside ng on init we can write this dot data subscription equals, and here is our subscribe. And if you don't know, the result of our subscribe is the subscription. This is why here we are writing our subscription. Now the question is when we want to unsubscribe from this subscription. And for this we can define onDestroy, which will happen when we are destroying the component. And here is ng on destroy, and we want to call this dot data subscription, here question mark dot unsubscribe. And we want to use here question mark because it can be undefined. And this is the line how we're unsubscribing from our subscription when our component is destroyed. Let's check this out. I'm here inside users. We have our data console log. Now I'm jumping inside home, and we don't have it anymore because we successfully unsubscribed from this subscription when we changed the route and our component was destroyed. Another variant that we can use instead of this is a sync pipe. This is why here I will comment this data subscription code, we don't need it anymore. It is much easier to just use an async pipe because Angular by itself will unsubscribe from this stream when our component is destroyed. And in order to do that, we can simply render this data stream inside our template, because typically we want to render some values from our stream. So here we have our stream and we're using pipe async. And actually we will talk about pipes in a later videos, but here just to remind you, we have some default pipes inside Angular with this pipe symbol, and here is an async pipe which resolves our stream, which actually means this will render a value. Let's check this out. As you can see, we're getting an error, no pipe found with name async. It is happening because inside our users module, we must add common module. So here inside import, I will write common module in order to use this pipe. As you can see, after we added common module inside our module, we don't have any error. Now here I am inside home, I am jumping to users, and here we're getting the re-rendering of our interval, which actually means this is our async property that we rendered inside the template. And this is exactly how you typically want to render values from observables, because we don't need to create subscription, we don't need to unsubscribe, Angular is doing everything for us because we're using an async pipe. Now here are some different ways how you can also unsubscribe from your stream. This is why here I want to uncomment this ngOn init, and here we won't use this subscription. But after our this data, we will write a pipe, because we want to use some methods before our subscribe. And first of all, here we can write take, for example, 1, which actually means this code is completely safe, because here our stream will emit just a single value. As you can see in browser, we're reloading the page, and here inside console we're getting data 0. Yes, here inside template we're still getting our values, because this is another value with the async. Let's remove it so it is not confusing. Most importantly, inside our console, we see data 0 only once, and we don't have any values here. And it doesn't really matter that here we have a subscribe, because we don't emit values for this subscribe. This is why take is exactly what you want, and typically you will use it with 1, because sometimes you really need just this one emission. Another function that you might want to use is take while. So here we can write a predicate. We have take while, and here inside predicate we can write value, and for example value less than 5, which actually means our observable will emit our values only until we reach 5. So here we have values from 0 to 4, and this is totally safe, because it will emit them only 5 times, and then this subscribe won't do anything. But actually the most popular variant is usage of take until. Why is that? Just imagine that you have here like 10 or 20 subscriptions, and then you need to create these subscriptions 20 times because you have 20 places with subscribe. And then inside your ngOn destroy you must write unsubscribe 20 times. This is a lot of code and this is difficult to read. This is why we have a better approach. So here on the top we want to create a value, for example unsubscribe with $, and here we're calling new subject. And inside we're providing void and we're calling it with round brackets. Now here inside our pipe we don't want to write take while, but we want to write take until. And here inside we're providing this unsubscribe. And now inside our ngOn destroy we can write this unsubscribe next, and after this unsubscribe dot complete. And you can say here, okay, but we wrote more code than previously. But the main point is now it doesn't really matter how many subscriptions you have. You can simply have here like 20 different subscriptions, and for every single stream you just write this thing, pipe take until this unsubscribe. You don't need to create any additional subscriptions, and they will be handled correctly. Why that and how does it work? So here we have our unsubscribe, and this is the subject, which means it can emit values. And actually this take until means that we are taking values, so we're emitting something only until the stream inside is still not completed stream, which actually means it will work until we're destroying component. Why that? Because here we have unsubscribe complete, which will finish completion for our stream. And this is actually the best possible variant if you have lots of different streams and you want to unsubscribe from them without usage of a sync pipe. Let's check if it's working. I'm jumping in the browser. Here I am inside home. We don't have anything. I'm jumping inside users. Here are our console log, and they are just coming and coming. But now I am jumping inside home and we don't have any console logs because this unsubscribe stream is completed. This is why this pipe is not emitting any values. And now here you want for sure to say, okay, but I don't really want to write all this code with subject and complete in every single component, and you are totally right. We can move this code in additional service. So inside your project you can create something like maybe unsub.ts, and this is just a class. So here we want to export an abstract class, and let's name it unsub. And here we want to just write implements on destroy. Now inside I will copy paste this unsubscribe that we defined in our component and completely ng on destroy method. And obviously comment we can remove. So actually we wrote the whole logic inside our abstract class. Now here we can jump inside our component, and here I can write extends unsub, which actually means we're extending the component based on our class. And here now I want to remove unsubscribe completely, we don't need it, and we can also remove ng on destroy because it is already implemented inside our class. Which actually means our code now is super clean, we don't have any additional variables, and here we have this unsubscribe and it is coming through extends. Let's check this out. As you can see inside console, we're getting classes using Angular features but is not decorated, which actually means we must here on the top write injectable. Let's check again, we don't have an error. Now here I am inside home page, I am jumping to users, here is our console log, I am jumping to home and we don't have console logs anymore. So here you learned how important it is to unsubscribe from your components and all your subscriptions. You might also get a question like this: what is change detection, how does onPush work, and why it is important to use that? And in order to understand that better, I already prepared for us a small project. As you can see here, I successfully rendered 3 to-dos. And in order to do that, I created 2 components, to-dos and to-do. And inside to-dos component, I simply have a list of our to-dos and nothing more. Inside HTML, I simply render child component in for loop and I'm providing a to-do inside. This is why inside our to-do I'm just rendering text, and inside our component I don't have anything except of this input. And the first question that should come to the mind when we're talking about performance and rendering is how many times my components are rendered. And actually you can't really find easily some method which will show how many times your components are rendered. This is why here is a small hack how you can find it out. What we can do inside our to-do, after our div, we can just call a function which will be check render. And just for you to know, all functions inside templates are being called in every single digest cycle. This is why here let's jump inside TS file and create this check render. And what it does, I want simply to return here true, and before this I want to write console log check render. As you can see here, we see our changes lots of times, and actually by default every programmer would expect that if we are rendering 3 components and we didn't do any changes, then we must just see 3 check render. Why do we see them that much? So here in total for every single component we see 4 check renders. Why is that? So first of all, Angular loads our component, this is where we see our check render, and then checks it for changes. And this is exactly what is happening for the component. These are normal 2 check renders. But then additionally we have 2 more when Angular runs second digest cycle. And this is happening only in development mode because Angular wants to be sure that we didn't make any mistake and that the whole tree of our components was not changed. And if you're wondering what is digest cycle or how Angular is checking our changes, we have DOM elements, this is what you see on the screen, and we have a representation of these DOM elements inside virtual DOM in Angular. This is just an object inside JavaScript with lots of properties. The main point is that every single time when Angular makes a digest cycle, it checks every single component from the root to the bottom level to see if there are any changes inside these components, and if we have any changes, then it re-renders our components. This is why actually the most popular error which people see nowadays is this expression has changed. And actually this error means that Angular did the second digest cycle, which is also synchronous like the first one, and is going afterwards. And between first digest cycle and second digest cycle, our application was changed. For example, it can happen when you're using things like mathRandom or maybe new date. These things will always return for us new data. But actually it is even worse, and in order to understand that, let's add inside our to-dos just one more input. So let's create an input with type text, and here let's create key operand, which will be change text. So let's create this change text inside our component to-dos. And here I don't want to do anything, just write console log change text. So let's check if something changed. First of all, here we have our check render on the beginning, but now I'm just typing something in the parent in our to-dos component, and as you can see, with every single letter when I'm typing, we have a re-rendering of all our child components. Which actually means this is exactly Angular digest cycle. We're changing the parent and it re-renders all our children. But actually for our case this is completely useless, because our input inside parent doesn't have anything to do with our children. We didn't change our to-dos when we are changing an input. And there is a fix for that, and it is called onPush strategy. So we must jump back inside our to-do component, and here inside component we want to add change detection, and here it will be change detection strategy dot, and here we have default, this is what we have by default, and on push. And actually with on push we will have much less changes. Let's check this out. I'm reloading the page. First of all, we're getting just 3 check renders, which is exactly what we wanted, because we just rendered 3 components, and after this I'm typing something in the parent, and we just see this change text, we don't see check render. Why it is happening? Actually, what this onPush does, it takes the component out of Angular digest cycle, which actually means Angular does not check this component anymore. But the question is when it will check this component, and it will re-render this component when our inputs are changed, which actually means in 99% of the cases you want always to use change strategy on push. But here is one more important point that you must know. I already said that if we are changing our input, then our component will be re-rendered. But what will happen if inside our to-dos we will create a button with click event, and here let's name it change array method. Here I'm closing our button, and let's write inside change array. And now here I want to define this function inside our to-dos, and what we want to do inside, we want to change the first element and just update the text, which actually means typically you will write something like this, dot to-dos. Here we're trying to access the first element, dot text, and we're providing inside foo. This is totally fine. I'm reloading the page. I'm just clicking change array, and as you can see, nothing happened. Our component was not rendered, and we still have here first to do. Why it is happening? Because actually here our to-dos is an array, and inside every single to-do we are providing an object, and here we didn't have a new object, we simply changed the property of this object by reference, which actually means reference to this object didn't change, and Angular doesn't understand that we changed some value and we want to re-render our component. Which means you never need to write this if you really want to re-render your component when you are changing props. You need to write it differently. Something like this would go. For example, we want to update the whole 0 component, and here we are assigning new object, and we are spreading inside this to-dos 0, which actually means we are taking all fields from to-do 0, and we just update text. This is why here text foo. And we don't need the first line here. And this is completely new object. This is why Angular won't be confused. Let's check this out. I'm reloading the page. Here is our first to do. I'm clicking change array, and here is our foo string. So our first component was successfully re-rendered, and we see just a single check render inside our console. And now here you for sure want to ask, okay, but if we are just reacting on the changes inside our inputs, will it really work with events inside our component itself? Will our component be re-rendered? So let's check this out. Inside our to-do component, we can simply render some local property. For example, here I will create a property some local prop, And after this, I want to create a button, and let's write here change some local prop. And here we want to call some function, for example, click, and here we are changing some local prop. So let's create this function inside our to-do. So here we want to update our local property. This is why here let's create some local property, and let's write inside a string some local property, and inside change some local property, inside this dot some local property, we're just assigning changed some local property, which actually means the only thing that we're doing, we have an event and we're changing local property, and we're checking if our component will be re-rendered. I'm reloading the page and I'm clicking here on change some local property. And as you can see, our first component was successfully re-rendered, which actually means it doesn't really matter that we have here change strategy on push, because our component will be re-rendered when some events are happening inside component itself. And the last question that we must clarify if it will work with observables. This is why in order to test that, I already prepared inside services to do service. And the only thing that we have here is a behavior subject. What I want to do now, I want inside our to-do simply get this filter, render it and change it. This is why here let's write that we have a filter with $, and this is observable of string. And here we must add a constructor because we want to inject this to-do service. So here is our to-do service, and we're injecting it inside. Now inside our filter we can just assign this dot to do service dot, and here is our filter with $. Now let's render this filter directly inside our component. So here let's create a div, and inside we're writing a filter value, and here I'm rendering filter async. And after this I want to create here a button to change the value of our filter, which is an observable. So here we have a click event, and I'm just writing change filter, and the text is change filter. Now let's create this change filter method inside our to-do component. So what we want to do inside, we simply want to call this dot to do service dot filter next, and let's assign some other value here, for example active. I will reload the page now, and as you can see in all our components we see filter all. I am just clicking change filter in the first one, and we get 3 renders. And this is completely correct because we must render 3 components, and this observable is updated everywhere, because actually all observables are also working together with onPush. So as you can see, by using onPush you are not losing anything, but you are getting much less renders, and it makes your application much faster. You might also get a question like this: why this error happens? And as you can see here, I reproduced the error, which is saying type number or null is not assignable to type number. And actually here is the code. As you can see, we have our app component HTML, and we just have here a single liner. We're rendering here child component, and this child component has a single prop, which is current page, and we're providing it inside within the sync pipe, which actually means here we are actually providing a number from this stream. Let's check this out inside app component TS. This is just a stream of one number, and we're totally sure that this current page $, is observable of number. And here is our child component. As you can see, nothing in HTML, we simply render our current page, and inside TS we have just an input current page, and here it equals 1. Which actually means here we defined that we're getting number. We can even write here that we're getting number, but we're still getting this error. And this error says type number or null is not assignable to type number. And as you can see, we're getting it exactly in this line where we're providing inside current page. And it doesn't really make any sense because we don't have null in any case. In the parent component we got number, in a child we even defaulted to 1, which actually means we could not get null at any case. But actually this is not how Angular works, because by default Angular thinks that inside observable we will have null. This is why it doesn't really matter what your code is. If you are writing a sync pipe as a prop, which actually means like this, not just inside template, then you will get this error. And you must really tell here TypeScript that you are getting number or null. And in this case, as you can see, everything is fixed, but actually it doesn't make your code more readable because this child component is for us completely isolated and we don't care from where we're getting values. And here we're saying, okay, I really want to get current page and it is a number. If it is not provided, I will default to 1. Which actually means this code is 100% fine. But we just have a problem from the Angular, because Angular thinks that this current page, which can be any observable, and essentially TypeScript even says that this is observable of number, inside this line when we're using async pipe, has as default value inside our observable number. And this is the problem. So the first solution you already saw, we're using here null. You could also write any, but it is even worse. But we also have another solution. I don't see a problem inside child component, and here inside our app component HTML we can make it differently, because essentially the problem is only in async pipe. What we can write is just ignore this null. How we can do that? We can write here ng container, and here we can write star ng if, and we're writing here current page async, and after this we're using as notation, so we're saying here as current page. So what this single line does, it creates local property current page inside ng container. So here we're closing our ng container, and now inside here we have access to the current page as a local property. And we're sure that this current page is always there because we wrote this async pipe inside ng if, which actually means if we're getting here null or undefined, they will be ignored. This is why here we can put this child inside our ng container, and now instead of current page async, we simply call here current page. And this is the fix, so we didn't use async pipe here as a property, we just moved it outside and we got local parameter. And as you can see here, we don't have any errors, and now it will work correctly. So essentially you are just fixing Angular here, because Angular is saying that your observable by default will always be null, which is actually logical from some perspective, but if you are sure that the value is there, then it is not that comfortable. You might get a question like this: how to handle errors inside async pipes? And actually this is a really nice question, because a lot of people are doing this incorrectly. Why is that? Because essentially everybody are doing HTTP request. So we're injecting inside our app component, for example, our HTTP, and this is our HTTP client. After this, what people are doing, they simply try to get data back, which actually means they're not using subscribe, they're just storing their results like this inside some property. So they're writing here this HTTP get, and here is some HTTP localhost 3004. And actually this code works, and we're getting back our users. And what they are doing inside the template, they simply get users with async, and this is it. And here is the huge problem. You should not use observables from HTTP like this inside your template. Why is that? Because it is not comfortable to handle errors there at all, and secondly, it is difficult to transform data or find mistakes inside your code. So what you want to do instead, you want to separate your things. First of all, here I will add ng on init, and inside we want to fetch our data. So we actually will write this code inside our ng on init. Additionally to that, we will use subscribe, and we will just put some values inside our object. So here we are getting back users, and now we want to create, for example, users property on the top, and now inside I will just write this users as an array. Also here on the top we must create an interface for our user, because it won't work without it. This is why here at least ID a string and maybe name a string. And here we're defining, okay, we have a list of users, which is a user interface array, and by default this is an empty array. But here now we're providing that we're also getting back our user interface array. And as you can see, we're getting here a local property, this users, and we can use it directly inside our template, and we're totally fine. If you want to handle errors, you can do it directly, because here we're working with RxJS. So here inside the subscribe, we can also have next and error, just like we did previously when we're handling error inside RxJS. But here you might say, okay, but I don't really want to have properties like this, I want to have an observable. For me it is not comfortable to work with local properties, I want to work with streams. It is actually much better to store your data as a state inside your application. And in order to do that, you can create a behavior subject. And we already did it previously. So here we are defining our users with new behavior subject, and we are saying that this is user interface array. And by default, this behavior subject is an empty array. We don't need these users, and then instead of this line, you can simply write these users with $.next, and inside we are passing our users. This is totally fine. Now you can directly render your users like this with a sync, but this is not an API call. It can't fail. This is just an array inside our observable. And if you really want something like isLoading maybe, you just create it. So we have here an observable isLoading, and we are also using here behavior subject, but it is Boolean, and by default it will be false. Now here, after we successfully got our users, we can just set isLoading back to false, and just before starting or fetching them, we can set it to true. So this is loading next, and here we have true, which actually means we completely separated our template and handling errors inside HTTP from a sync pipe. Because it is not comfortable to handle errors inside a sync pipe, we are using a sync pipe when we want to render safe streams of data. You might get a question like this: what is ng-container, ng-template, ng-content, and ng-template outlet? And actually all these directives are sounding really similar. This is why a lot of people are confused what directive they should use. So first of all, let's look on ng-template, and it is much easier to understand on the example. What I want to write here, I want to write div. Here we have ng-if article else loading. Here I'm closing the div, and inside I'm rendering article.title, which actually means I want to render inside this div article title property. But if article is not there, then we're rendering loading. In order to make this code working, we must create an article property inside our app component. And as you can see here on the top, I already prepared an article interface, which actually means here we can create an article and say that this is an article interface or null. And here I want to create ID1 and title foo. So we're getting our article, and now this stuff will be rendered. But this is not all. The question is now, what is else loading? Because actually this is ng-template, and we must create it in order to use it. So here I will create ng-template, and now I put here hash loading. This is exactly this else loading. Here I'm closing ng-template, and now inside I can write whatever markup I want to. For example, here we can write div with loading indicator. Let's look in browser. As you can see here, foo was rendered, because actually here we have our article inside our component, and this article title is there. But what will happen if here we will just return null and not the subject? As you can see in browser, we're getting loading indicator. What is that? This is this ng-template. So what is ng-template? This is a special Angular directive, which means that this ng-template will contain inside a part of the template. But most important thing to remember is that this ng-template is not just rendered like normal markup. This is just a variable loading, and it references this ng-template, and we can use it later, for example inside else condition, inside ng-if. But actually, just for you to know, this is what Angular does under the hood. It uses ng-templates really a lot, and actually this div is not looking like this inside Angular when it converts it. It looks like this. It has ng-template, and here ng-if directive, here we have condition article, and also we have another directive, ng-if else, and here we're providing loading. And actually this is exactly the same what we have on the top. So here I am closing ng-template, and now inside we have our markup, for example div with rendered article.title. Now as you can see here we have two loading messages, which actually means this code does exactly the same like this code. But Angular simply unwraps this code with ng-if and else in this code with ng-if directive and ng-if else directive. Now let's talk about ng container. Typically your markup is just like this. You're writing some div, then inside just for markup and CSS you write one more div and then one more div inside if you need to. The main problem is on some divs you have some classes. For example, here class nested and here class parent. The main problem is that sometimes your CSS really wants to be nested like this. For example, parent and nested as a child. But when you are writing Angular markup, you are using things like ngIf, ng4, and then you can really miss correct nesting because you have just some divs just for the sake of use ngIf or ng4. This is why actually there is a better variant which is just for Angular, which actually means we're creating ng container which does not exist inside DOM. And we can write it like this. For example, here we have ng container. And here we're using ngIf numbers. Now here I want to close our ng container, and here I want one more ng container, and here I will write ng4 for let number of numbers. And I'm closing this ng container also. Now inside I just want to render a number. But in order for this code to work, we must create these numbers inside our component. So let's say that our numbers is just an array of 1 to 3. As you can see in browser, 1 to 3 was successfully rendered, but now let's look on the markup. As you can see here, after each one tag we have just 1, 2, 3 and comments for ng container to understand better from development perspective what is happening here, but we don't have here any additional containers. If you really don't want any markup inside your DOM, then you can't really use here div container and here div container, because then inside DOM you will have two more containers that you might not need. This is why inside Angular we have ng container. This is a directive which exists only inside Angular, and Angular does not render it inside DOM. Now let's talk about ng content, and we're using ng content just in a single case, when we want to render some markup from the parent inside the child. What does it mean? App component is my parent, and here I have a child component which is completely empty. What I want to write inside my child is this tag ng content, and I want to close it here. So actually this does nothing, this is just a placeholder where we can inject some markup from the parent. This is why now we can jump inside parent and we can try to render our child component. So typically you will just write child and maybe some inputs, but it is not all. Inside child you can actually write some markup. For example, here you can just write div with some text or maybe even variables from our app component. And as you can see in browser, here is full text, because this is exactly what we wrote here. And as you saw, we didn't have any markup inside child. This is the markup from the parent. And this is the best possible variant when you want to make your child flexible and pass some markup from the parent to the child. And the last thing what we want to talk about is our ng template outlet. As you can see here, I have ng template just like we used in the first question. But instead of just hash loading, I wrote here loading template, so we understand better what we're talking about. And now inside our app component, I still have this article with ID1 and title foo. And now let's try to use ng template outlet. So in order to do that, we simply write here ng container, and we're closing here ng container, and inside we're providing star ng template outlet. And this is a special directive which allows us to render inside ng template. This is why here we can provide loading template just like a template inside our ng container, which actually means this code won't be just rendered on the screen. So if we want to render it, we can use ng template outlet. And as you can see in browser, our loading was rendered through this directive ng template outlet. But it is not all, you can also provide parameters inside template outlet. This is why it is so flexible. So we can create here ng template, and let's name it, for example, article template. And inside we want to provide our article, which is an object. And in order to do that, we're using let dash and then property notation, which means we can name it article, and it will be our local property. And here we're referencing it like an article. Now here I will close our ng template, and now inside we can just write some div with this article. So here I am rendering article.title. And now you for sure think, okay, but this article title comes from our component. But actually it is not. This ng template is fully isolated, and this article title is coming inside let article, which actually means here we have ng template outlet, and here we must write that we want to render article template, but we want to provide inside context. This is exactly how we are providing variables. And our context is an object with field article. And article here is exactly our article that you see in component file. So this article comes here as a context, and we're rendering this template outlet, this article template, with this object, and inside we have an article. So if we want to read this article, we're using this construction, let article, to get it from the context and to render it inside. And as you can see in browser, our foo title is rendered, and it is coming from our article. You might also get a question regarding animations inside Angular. As you can see here, we have a question when to use Angular animations and not CSS animations. And also after this, how to animate the following example. And here we have just a button with click fade in and out, and we have a div with ngIf is shown, which actually means we must see this block with fade in and fade out animation. And here is my answer to the first question. You should not use Angular animations at all if you don't need to work with TypeScript or JavaScript, because essentially CSS animations are working easier and faster than Angular animations because they are done without TypeScript. What does it mean? If you don't have any variables or any logic regarding your TypeScript component, you should not do it with Angular animations. Just use plain CSS animation, it will be fast and it will work out of the box. So you must use Angular animation only if you care regarding state of your component, and when this state changes, you want to apply some animation or changes. So as you can see, I already prepared here the code. This is our button with fade in, fade out, and div with ngIf is shown. And now inside our component we have is shown false, and here we're just changing this boolean inside our fade in out function. As you can see in browser, we have fade in out button. I am just clicking and we see this text. I am clicking again and this text is hidden. Now we must apply animations to this button. And in order to do that, first of all, we must jump inside our app module, and inside our imports, we must add browser animations module. And as you can see here, this module is coming from Angular platform browser animations, which actually means from the package Angular animations, so we don't need to install anything additionally. Now let's jump back inside our app component. And here I want to create a new property animations, and inside we're providing an array. So here I want to provide a property fade in, and I want to create it here on the top. So what is fade in? This is a trigger. And this trigger with the name, for example, fade in, will come from our Angular animations. And here inside we have a definition what will happen with this trigger. So when this animation is triggered, and here I will write enter transition. Now here on the top I want to create enter transition, and this is a transition also from Angular animations. And inside here we can put :enter, which means it will happen when we just created an element. So ngIf is exactly for this. And as a second parameter we have an array of our steps which will happen one after another. So here first of all I want to write style, and this style also is coming from Angular animations, and inside we're providing some styles. Let's say opacity 0. And after setting our element with 0 style, we want to animate it. This is why here is animate function, and inside we will provide our animation 1 second is in, and here styles that we must do after our animation will happen. And here we're providing opacity 1. What does it mean? We have here an enter animation, which means when our element is starting to be shown, we want to apply this animation. And here we're defining the transition, which will happen on enter, which means on creating, and here is the list of our steps. At the beginning, the style of our element will be opacity 0. After this, we will apply animation, 1 second is in, and after this, the style will be opacity 1. So we successfully defined our animation, but we didn't apply it to our DOM element. This is why inside our app component we have this div, and here we want to apply our animation. This is why here we're writing add fade in. This is exactly the name that we wrote here inside our trigger. Let's check if it's working. I'm reloading the page, I'm clicking on the button, and as you can see now, this text is animated. Why it is happening? Because we applied this enter animation through trigger and transition. Now let's do exactly the same but with fade out. This is why here let's create one more animation, fade out. And here I will just copy paste this fade in trigger. So here we're creating fade out trigger. The name will be fade out and it will be exit transition. Now here I will copy paste fully our enter transition and rename it to exit transition. Now here we must change :enter to :leave. We also have here an array, but we are starting with opacity 1. After this we have is out animation, and at the end we will have our opacity 0. Let's apply this animation also to our component. So here we will have fade out. As you can see in browser, we have animation on fade in, and additionally now we defined animation on fade out. So actually we solved this task, but I want to show you other ways. So here I want to write a new animation fade in out, so we will combine them in just a single animation. Now here I want to comment out all code that we have and just create a single animation, which will be fade in out. Now here on the top, I want to create this fade in out property, and it will be our trigger with the name fade in out. Now inside I want to create an array, so as you can see we are not creating additional variables, we will write everything here. And first of all here I want to define a state, and actually the state is a possibility to define state of our animation that we can reuse later. For example, here we can define an open state, and we are setting as a second parameter styles. And here we have our styles with opacity 1, which actually means this is exactly the code that we wrote previously, but here we're just defining our open state. After this I will define close state, and here we will have style with opacity 0. And actually these two lines are not doing anything at all, this is just something that we can use later. And we will use it here. We will apply here transition, and we can define here open, and then we have an arrow to close, which actually means this is a transition when we are coming from open state to close state. And here we can write as a second parameter an array with animation, and here we have our animate 1 second is out. And now we can do exactly the same but close to open. And here we have 1 second is in. Let's check if it's working. As you can see, I'm clicking fade in and fade out, and it doesn't work, because now we must use it differently, because we have here states. So here we have our fade in out, but we must define it with square brackets, just like an attribute. And now inside we want to apply this ngIf. So actually this ngIf is not needed anymore. We can just define it here. We can write is shown, and when this property is true, then we want to apply here open. In our case, we want to apply here close. And as you already understand, open and close in this case are our states that we defined for animation, which actually means if this variable isn't true, we have an open state, in other case we have close. Let's check if it's working. I'm clicking here fade in, we have animation. I'm clicking fade out, and we have animation again. And as you can see, we actually wrote less code, and it is much readable because we moved our styles outside to the states. And here with this notation and arrows, we can simplify from what state we are coming to what state. Now I want to show you wildcards. What does it mean? Instead of open close here, we can write, for example, open to star, and here we have star to open. What does it mean? We are not defining here to what state we are coming. We are just saying if we are going from the open state to any other state, which means star, then we want to apply this animation. And here it's the same. If we are coming from any state to open state, we want to apply this animation. As you can see, it is still working in exactly the same way, but now we're using wildcards here. You might get a question like this: what is as keyword, what does it do, and did you use it previously with combine latest? And actually we already used as keyword in one of the previous videos, but let's just remind ourselves how we are using it. So let's say that we have here a div and you want to render something inside. But the information that you want to render is coming from the stream, which actually means here you want to use ngIf. Why ngIf? Because typically you want to wait for the value from the stream and then to render it inside. So if you are getting, for example, current user, then it will look like this. You have current user $, because this is a stream, you are using here a sync pipe, and after this you are writing as current user. And now here you have a local property current user, and you can render all properties that you want. For example, current user name, then maybe current user surname, age, and so on. In the case if you are not using this construction with as, it means that you are writing something like this. You just use for every single property here in a sync pipe, like this. And then you are wrapping this with round brackets, and you must put here a question mark. This code will work, but the main problem is that you have here several observables with the sync pipes, so essentially Angular creates a new subscriber for every single async. First of all, this code is more difficult to support and understand, and secondly, we have too many subscribers where we don't need to. This is why this code with ngIf and just local variables is much cleaner and easier to understand. So essentially here you have just your stream with a sync pipe, then as keyword, and here the local property, which can be any name. And the last question that we got, how we can use it with combine latest. And I hope that you watched my video inside the section of React.js where we talked about combine latest. This is why here inside app component.ts, what I want to do, I want to create several streams. For example, we have a foo stream, and I will use here off just to create fast stream. Let's say here we have a string foo. After this I will create bus stream and bus stream. And let's change here our values. So we have 3 different streams, and in this case we will write 3 different async pipes inside our HTML. It may be fine, but just imagine that we're talking about 3 different objects from these streams. And then we have local properties from different objects. And let's say that we have a div where inside we must use value from the first stream and from the second stream. Even using as syntax like this will become uncomfortable. This is why we can use here combine latest to make this code easier. So we can create here data property, and here inside we can assign combine latest function from React.js, and here I want to write an object. Now here as a keys we can write whatever, but as a values we must provide streams. So here I will assign inside foo property foo stream, inside bar property bar stream, and inside bus property bus stream. And obviously all this must be written with this keyword. Now let's check what we're getting back. As you can see here, data $, is an observable of the object where we have foo, bar, and bus, and they are all strings. What it does for us, it combines the stream, and we have just a single stream for the whole component. Now we can wrap the whole component just with a single async pipe. So here I will write data, async, and here data. And now this will be my main container inside this file at all. This means that all my streams are going inside this data $, and now inside I can just render local properties. For example, I can render here data.foo, but I can also render here data.bar. And as you can see in browser, we successfully rendered here foo and bar, which actually means combine latest is a great way to use it together with as keyword, as it allows us to write less code and just use a single async pipe for the whole component. You might get a question like this: what is our te and JIT compilation, and what is the difference? So actually our te means ahead of time compilation and JIT means just in time compilation. And these are 2 different ways how Angular compiles our application. Typically, previously, we used just-in-time compilation in development and ahead of time in production. What is the difference? Actually, inside Angular, as you saw, we don't have really templates or CSS, and we have TypeScript, which actually means all this stuff is not working inside browser. It must be transpiled from TypeScript to JavaScript and from templates of Angular in real JavaScript functions. And we're doing this in development with the help of just-in-time compilation. What is ahead-of-time compilation? This is what we're using for production, when we really build our application. What is the point? We transpile all this stuff in JavaScript beforehand and not in runtime how we're doing in development, which actually means we simply throw our JavaScript and CSS, which was prepared to the browser. We don't have Angular templates because they are now inside our JavaScript, and we don't have some isolated CSS. We don't need to calculate anything. We just have bundled files which we're using in production. This is why actually it is much faster in production than in development. Additionally, in just-in-time compilation, we're getting less errors than in ahead-of-time compilation, and this was really a problem before in Angular, but not now. Why is that? Because actually starting with Angular 9 and Angular Ivy, and we will talk about Angular Ivy later, we can use ahead-of-time compilation in development mode, which actually means we're getting exactly the same errors now in the development watch mode and in production. This is why you will get the same errors and you can directly fix them during your development and not when you are building your application. You can get a question like this: what is the difference between component and directive? And actually, first of all, I want to remind you how we're defining component and how we're creating directive. So typically, if you create something like child component, you will call it like this: child, and then inside you may have some props, for example, current page, and then you are providing here a value. How we're doing it with our directive? We typically have just some element, or maybe even component, and then you apply here some directive. For example, directive highlight. And here you are closing your div and you have some text. So we typically are using components to create some UI parts or widgets, which actually means, for example, you have a sidebar or maybe popular text sections, or you are implementing a feed inside your application. You will for sure isolate your logic inside this component. And you are using directive when you need some additional behavior to existing DOM element. So as you can see here, we already have our div element and we're adding here some directive to add additional behavior. So we're using components to break our application in smaller pieces, which we can easily implement and support. And we're using directives just when we need to add additional behavior to existing components or DOM elements. And the last difference that we have, inside component we can write TypeScript file, which actually means the whole component, and also HTML file, our template, and also CSS. Inside directive we're just writing the logic, which actually means we don't have a template, we have just a TypeScript file for our directive where we're writing our behavior, which will access DOM element and change it. You might also get such an nerdy question like this: what is the difference between structural directives and component directives? And actually here the problem is just in naming. You are using this stuff every single day. So first of all, what are component directives? And actually when we're just creating a component like child, current page, this is actually not a component. This is a component directive which we are creating with the word component. But essentially inside Angular we are just calling it component. Then we have structural directives, and inside your applications you won't create structural directives that often, but we have 3 of them which are coming together with Angular, and you for sure used them. For example, here we have a div with directive highlight, and here we can use ngIf. And actually ngIf is one of the structural directives. Why that? Because essentially it renders the element or it removes the element from the DOM tree when we have the condition true or false. Another structural directive that you for sure use is ng4, and actually it is a structural directive because it creates and fills the DOM element with the list of the elements that we're creating on the fly, which means it is also a structural directive. And the last one in the list is ng-switch, which does exactly the same like ng-if but with else parts. And the last one is attribute directive. This is exactly the directive like we are creating them normally. So for example, highlight here is an attribute directive which can change the appearance or behavior of the element or the component. You might get a question like this: create a directive which changes the background of the element. And actually this is a question just to understand if you know how to create directives inside Angular. So here I am inside source app and I want to create a new file for our directive, and as we're changing the color, I will just name it background changer.directive.ts. Now inside I want to create a class, so here our class will be background changer directive. And on the top of the class we must define that this is a directive, and inside we're providing an object with our selector. And just to remind you, our selector we're writing inside square brackets in the string. So in our case here it will be background changer, which will be camel case. Now we must register our directive. This is why here on the right I will jump inside app module TS and register it inside declarations. So here we will have our background changer directive. So our directive is registered. Now the most important part is to get access to our element. And as we are attaching directive to the element, we have direct access to this DOM element. This is why here we must create a constructor, and inside we are getting a property element, which is our element ref. Now we could use here ng on init or ng after viewing it, but we can also write our code directly inside constructor. So here we have access to this element, and this is an element ref. And it is important to remember that element ref is not a DOM element, so you can't really apply your background here. What we want to do, we want with dot to access our native element, and this is exactly our DOM element. And we can write here, for example, dot style dot background color, because this is exactly what we want to change. And for example, we want to change it on initialize to yellow. Now after this we must jump inside our HTML and create some div. For example, here is our div hello Angular, and I want to attach here our directive. I'm just writing here background changer, just like we created inside our directive. As you can see, we don't have any errors. And inside our browser we can see our hello Angular element, and background of this element is yellow, because actually we attached here our background changer directive and it was initialized, and on initialize of our directive we successfully changed the color of the native element, which is the reference to our DOM element. And here we have three questions which are related to pipes. So first of all, what are pipes? What building pipes do you know inside Angular? And create a simple pipe. So the first question is, what is pipe at all? And actually here inside div we might render some property. Let's say it is text hello. And after this we can put a pipe and then use some pipe, for example uppercase. And actually here I used the default pipe inside Angular, which will obviously transform our text to uppercase. So what is pipe? This is simply a function which we can apply to some expression inside Angular template to transform it to another value. And if we will name some default pipes, we will understand the usages. So as you can see here, we have uppercase, we also have lowercase, we have also date, so we can format correctly our date time. And we have a pipe to correctly show our JSON property. And we can even apply several pipes. For example, here I can write current date, then pipe, here will be date, which means we are using date pipe, and after this uppercase. And now here inside app component I want to create current date, and I will assign here new date. And let's look in browser. As you can see here, our date was uppercased because we used here uppercase, and we used here a date pipe with the default formatting. This is why here we are not getting datetime, like we created the date, but nicely formatted date. And the last thing that you need to remember regarding pipes before we will start to implement our custom pipe is that there are two different versions of pipes. We have pure pipes and impure pipes. For example, if here we have div and inside we are rendering some property, let's say foo, and here we want to apply some pipe, for example bar. If we just tell Angular that we want to apply bar pipe only when foo changes, this means that our pipe is pure, because it doesn't need to be checked every single time and Angular won't check it with every life cycle. If we are saying that bar pipe is impure, which means it must be called every single time on every life cycle, doesn't matter if foo is changed or not, then it is impure pipe. With that knowledge, let's build a pipe. So what I want to build, here I want to build a full name from the object, which actually means here we have some person, which is an object, and we're applying here custom pipe full name. And this custom pipe will transform this object to the string of name and surname. So first of all, for this we must create an object inside our app component. So we have here a person, we know this is an object, and we have here name, for example foo, and surname will be bar. Now let's create our pipe. So as it is full name pipe, let's name it full name dot pipe dot ts, and inside we must export our class. So it is full name pipe, and we're writing here implements pipe transform. And here directly we're getting an error that property transform is missing. And this is exactly what we must implement inside our pipe. So here we're writing transform, and inside we will get our value. And actually we will get a person, and we don't know what properties we have inside. This is why I will write here any. Now inside I want to return person.name plus here will be a space and then person.surname. And now on the top we must define that this is a pipe. This is why here we are writing pipe decorator, and inside we are providing an object with at least name, and here we must create our name of the pipe and it will be full name. Also additionally we can provide here pure, and we can set it to true because we really want to call this pipe only when the value of the person changes. Now we must add it inside our declarations. This is why I will jump inside our app module, declarations, and here we want to write our full name pipe. Now when we are jumping to the browser, we see foo bar string. How it is happening? We have inside our app component this person, this is an object, and we're applying here full name pipe, which transforms our object to just a string with surname and name. You might also get a question like this: why it is bad to call a function inside the template? And actually in the previous video we talked about pipes and we created this person full name pipe. And we could do that differently. For example, we could just create a function get full name. And here we're returning a string. So what we're doing here, we simply return the same code like we had inside our pipe. We could write here that we are concatenating this person name, then space, and here we have this person surname. And now we can simply call this function directly inside our markup without any pipes. So here I am writing get full name and it will work out of the box. As you can see in browser, we're getting foo bar, which is exactly the same like a pipe. So this is exactly the question, why it is bad to call functions like this inside your markup. And the main problem with this approach is how comfortable it is. We simply create some function which is based on some properties or some calculations and it just works. But the main problem here is that Angular, when it runs digest cycle, doesn't really know the result of this function. It sees, okay, we have getFullName function, I must execute it to understand if the value changed or not, which actually means every single function inside your template will be executed in every single digest cycle. And in order to test that, I want to comment out this div and add here a button. So let's say that we have a button that will just trigger a digest cycle. This is why here let's add a click event, for example with the name test. And here inside I will write trigger change detection. Now let's create this function test inside our component. And we won't do anything inside this function, I will simply console log test and nothing else. Let's look inside browser. We don't have any console logs here. Now I'm clicking trigger change detection and we're getting our test. But the question is now how many times this function getFullName was called. So here I can write getFullName and let's see how it goes. First of all, at the beginning we got this function already 6 times. This is because we don't have on push and this is the default behavior and we're on development mode, so we have double digest cycle. But additionally to that, every single time when I click on trigger change detection, we're getting twice getFullName, which actually means once for the development mode and once to recalculate it. So this function is being called in every digest cycle. And at this point you might say, okay, we must write here on push change detection and it will help. But unfortunately it won't, because these are changes inside our component. We are not affected from the changes from the outside. This is exactly the changes inside our component. The main point is that you need to use functions inside your components not that often. But we must remember about balance. Essentially calling getFullName here when we have just a small application is nothing to be scared about, because our application won't break, it won't be laggy because it is quite small. But if you have a huge application and you have performance problems, then you must for sure look, maybe you are writing too much functions inside your templates and then you are getting lots of calculations. This is why I highly recommend you from the start, when you are writing code, every single time when you are trying to call a function inside your template, you must think, do I really need this function? Can I solve it differently? And essentially there are 2 possible ways how you can fix this problem. First of all is make all your calculations that you want to make beforehand. For example, in our case here, we have a person already inside our app component. We can, based on our person, just create a full name property. And here we can simply assign this line that we're writing here inside getFullName. Now we can simply remove this function and just use fullName property inside our template. We won't have any calculations at all because this is just a variable and nothing more. Sometimes you want to create such variables when you fetched your data, or maybe just on initialize of your component. Another variant to solve this problem is by using pipes, and this is essentially what we did in previous video. Instead of just full name property, we created a pipe, and here inside pipe we passed a person, and as you can see inside our full name pipe we wrote pure true. This is exactly the option which will prevent Angular digest cycle from recalculating this line, because actually here nothing was changed, our person stays the same, we don't need to do anything. But in the real world you don't really want to create lots of pipes if they are not reusable. This is why in 90% of the cases it makes a lot of sense to simply create additional properties beforehand and use them later inside your template. Another question that you might get is, what is Angular Ivy? And actually Angular Ivy is a render engine inside Angular which was introduced somewhere around Angular 8 or Angular 9. And actually it was the third rewrite of Angular rendering engine, but the most promising. The main idea was that they could compile all components separately and not like one huge bundle. With that, we got a partial compilation with every single change of our components, and we don't need to wait for the whole tree. Additionally to that, Ivy leverages tree shaking. What does tree shaking means? That we are removing all modules that are imported but are not used inside our application. So our bundle is simply much smaller. And the last point that we got from Ivy, we now have our TE inside development. Just to remind you, we already talked about ahead-of-time compilation and just-in-time compilation. The main problem was that previously you got different results and different errors in your development server and when you are building your application. Now we're getting exactly the same errors because now we have our TE in development and in building for production. Another question that you might get is, what are interceptors inside Angular, and write an example of interceptor inside Angular. So the first question is, what is interceptor? And actually you can understand it from the name. It is something which intercepts our request to API and makes some changes inside this request, which actually means between this HTTP GET, for example, and calling our API on the backend, there will be interceptor, which actually means our request will be changed. And we typically use interceptors, for example, to write some headers inside every single request so our backend can understand if we are authorized or not. Now let's try to write an example of our interceptor. This is why here inside source app I will create my interceptor.service.ts. So here, as always, we must write injectable, and we're exporting here our class, which will be my interceptor service. Additionally to that, we want an implementation. This is why here implements HTTP interceptor, which actually means here now we're getting an error what we need to implement. And inside HTTP interceptor, we must have a function intercept, which is exactly to do something inside and return our updated request. This is why here let's create our function intercept, and we're getting here HTTP request. And here typically we're writing that this is HTTP request of type any, because we don't know exactly what request it is. And also we have a next function, which is HTTP handler. And it must return here an observable of HTTP event with type any. Now the only thing that we want to do inside is simply return next.handle, and inside we want to provide our HTTP request. And actually here I make a typo. Here it must be a parameter HTTP request. So we're getting inside our intercept function HTTP request and next, and here we're returning next handle HTTP request. What it does, it simply says, okay, we want to proceed with our request because we're finished with our interceptor. So here we're calling the next handle and we're providing our HTTP request. But actually we didn't do anything at all inside our interceptor. And typically what you want to do, you want at least to change headers. The main point is we can't change our HTTP request. In order to change it, we must make a clone of it and then change it. This is why instead of HTTP request, we want to write .clone. And this function will create a copy of our HTTP request. Now inside clone function, we can provide an object with set headers. And as you can see here, we also had set params, which can be also useful. And inside set headers, I want to provide an object with some property, for example, API key. And here, let's say we want to provide a string 12345. So here we made a clone of our HTTP request, we set our headers, and this is an API key 12345. In other case, you might want to provide a token for authentication that you typically store inside local storage or inside your cookie. So we successfully created our interceptor, now we must register it correctly. And we're typically registering it inside our app module. And in order to do that, we must create providers as an array. And typically we just threw there a service and this is it. But with HTTP interceptors, we're providing them differently. Here we have an object and we have a property provide. And here we're providing HTTP interceptors. Another thing that we must write here is use class, and here is our myInterceptor service that we just created, and the last property is multi-true. For HTTP interceptors, we must always set it to true. And this is how we're registering our custom interceptor. So here we have our app component and the geoinit function. What I want to do here is call this .http, and I want to try and make a get call. And I already have an API, localhost 3004/users, which must return a list of users. But actually here I will just call subscribe and I am not doing anything with this data. What I want to do inside browser is simply check what we are getting inside our request. So here I'm clicking on network and we can see our user's request, and this is response with user data. But what is interesting for us is our headers. As you can see here, we have response headers and request headers. And we have here a new key, API key 12345. This is exactly what we said inside our interceptor, which actually means our interceptor is successfully working, and now we're adding this custom header to every single request which we're doing for the backend. And this is exactly the purpose of interceptors inside Angular. You might get a question, what are generators and how you can use them? And actually generators is a way from the console to create different entities inside Angular, which actually means here I am inside console and I can write ng generate or just g, then module, and let's name it foo ---- routing, which actually means we want to create a module foo and routing for it. As you can see here inside source app, we have now a folder foo, and inside we have foo module with imports of common module and routing module in the separate file. After this, you typically want some components, so this is why we're writing generate and not module but component, then foo / for example home. And it is generating for us the new folder home, and here we have a lot of stuff like CSS, spec, HTML, and TS. And inside we have just an empty component and some default markup. So generators is just a possibility of Angular CLI to generate for us different stuff. But essentially I am not a huge fan of generators because sometimes you want different nesting or different component structure and so on. And in every single team you may have different rules, and then your generators won't really help you. What is really easier for me is just copy-paste the whole component. Let's say here we have the whole users module. I can essentially just copy-paste the whole module, then create a folder here, for example bar, and now here we're creating bar module.ts. I am pasting everything here and just change. For example, I'm removing component and service. Here we don't need routes at all maybe, and I'm just renaming my class to be bar.module, and I don't need anything here. It might look like I spend a little bit more time, but actually I'm doing exactly what I need, and typically if we're talking about big project, all your modules will be looking the same, which actually means you can just take some module which will be super similar to the module that you want to implement, and then it is much faster to just copy-paste and remove some stuff that you don't need. You might also get a question like this. What are Angular guards? Write an example of code to protect a route with both synchronous and asynchronous version. And actually, what is Angular guard? This is a possibility to protect our routes from accessing. So typically we're creating a service, which is our guard, and then on our route we're writing can activate and we're writing a guard inside. So let's try to implement this now. And here inside source app we can create a new guard. And let's name it, for example, auth guard.service.ts. Now here inside, first of all, we need injectable, and secondly we must export our class auth guard service. And here we are writing implements can activate, because this is exactly what our guard needs to implement. As you can see, we are getting an error that property can activate is missing, and this is exactly the function which will be called to check if we can access this route or not. This is why here we can write can activate function, and it must return boolean. So actually just for testing we can simply return here true, and then try to protect some route. In order to do that, we must register our auth guard inside service. This is why here we're adding providers inside our app component, and here we're writing our auth guard service. And now we can jump inside our users module, and as you can see here we have a path and component. And let's say that we want to protect it with the guard. This is why here we're writing can activate, and here we have an array, and inside we're providing our auth guard service. As you can see in browser, I have two links, home and users, and if I'm clicking on users, we can access this route and our users content is rendered. But what will happen if inside our auth guard we're returning false? As you can see now we're on the home page and I'm clicking on the users and we can't access it at all, because here we're getting false and nothing is happening. Our route is not there, it is not changing, and we're not on /users. But in the real application you want to check something, and actually what we wrote here is a synchronous version to implement a guard. What we can check now here, for example, if we have a local storage item. So here, let's say that we are getting a token inside local storage, and if we have this token, then we want to return true. In other case, we are returning false. Sure, this is not the real check for production, because in the real project, you must fetch a user, and only if you have a user, then you can access your private route. Here we are not doing that. This is just so you can see how it works in the real world. As you can see here inside browser, I can't access users because I don't have this property inside local storage. But if I'm jump inside local storage and I'm creating a token property, doesn't matter what is the value, I can access users because this token is set. So this is exactly the example of synchronous query. I will comment it out, and now I want to write a synchronous query. And this is exactly what we're using inside real application, because essentially not a lot of people need synchronous query, because we're getting our user from API, which means this is a long process and we have the observable. This is why here we can write, can activate, but in our case here, we don't want to get a boolean back, we want to get back an observable of boolean. Now here we must return an observable. And typically in your application, you will have some service with the user, for example. We don't have it here. This is why I will simply write off and here true, which actually means if our stream is true, then we're logged in. In the real application, you can inject inside this service another service, for example, user service, and then you will have something like this users service, and here maybe it's logged in, which is an observable, and if this stuff is true, only then our user can access this route. But as we don't have such service, I will simply write here observable of true, and it will do exactly the same. So here we want to write pipe map, and inside map we are getting our value. So essentially it will be is logged in. And now inside we can check if we are not logged in, we want to redirect a user and return here false. In other case, we want simply to return true. And in order to navigate the user here, we must inject router. This is why here we have a constructor and we're injecting our router from router. So here we have access to the router. Now, if we are not logged in, we can simply call this router.navigate, maybe by URL, and here we're just throwing the user to the home page, which essentially is the similar code like our synchronous version, but it is asynchronous. Here we have our observable. This is why we're using pipe map. This is React.js. We're getting access to our isLoggedIn property, and if we're not logged in, then we're making navigation and we're returning false. And this return is important for Word. In other case, it can't be understandable if we can access this route or not. Let's check if it's working. I'm reloading the page, and here we can jump to our user. And here, if we have an observable of false, then we can't jump to this page. And this is forbidden, and we are redirected to the home page. You might get a question like this: how to load module on demand, lazy loading? What are the benefits of lazy loading? So the first question is, what is lazy loading and why do we need it at all? And typically when we have all our components and modules and services, everything is bundled together for production in a single JavaScript file, which essentially means it will be quite a big file with Angular inside, all dependencies and all our code. And actually for the small and medium projects, this is completely fine, it will work. Your bundle might be like 1-2 megabytes, it is fine for your production. But if you are working on a really huge application, it will take a lot of time and effort to load your bundle in the browser. Why is that? Because actually you will try to load like 10 or 12 megabytes of data, which is really a lot, and JavaScript in browser must parse the whole code. This is why we have lazy loading, and typically we're building it around routes, which actually means we're loading only code that we need for this specific route, and then when we're jumping to the next route, then we're loading the second chunk of data for that route. And inside Angular we can do it really easy. We can simply jump inside our source, app, and here we still have our users module. This is our module, and here is path users and our components. But the main point is that here inside our app module, we still have users module. this import should not be there if we are talking about lazy loading. If we are writing code like this, it will be bundled together in a single bundle. So we must remove component from here. Now we want to jump to the routing because our component will never be loaded because it is not imported. And here inside routes we can create a new object with path, and in our case it will be users, and here we are writing load children. But here we are providing a function and we are calling import. And now inside this import we must put the relative path to our module. So here I have users and then users module. And now after the import we are writing then, we are getting our module and we are calling m.users module. So actually this is exactly the line how we will import our module, and it won't be bundled together. The bundle will create a separate chunk just for this routing with all things that we need for this route, and now we will load it only when we are jumping to users module. Let's check if it's still working. Here am I inside the browser and we are interested in the network. And as you can see here inside network I have different stuff, like main.js, vendor, and so on. I will clean everything and click on users. And as you can see here, we have just a single script, source app users module. This is exactly our chunk for just this page. But as you can see here, we have a problem that we are on /users, but we don't see our content. And this is happening because of our routes. Now we are talking about this module on this specific route and this path is wrong. Here should be just an empty string because we don't have a nested path. And now as you can see it is working and we successfully rendered our lazy loaded module on this specific path. You might get a question like this. Write an example how to inject a module with some configuration. And actually here the question is going in the direction of for root. So let's try to create a module and see how it will work. So what we want here, we want to create some module, for example foo, and here I will write foo module ts. And actually I just want to copy paste our user module and change it a little bit. So here I removed everything that we don't need and we have our foo module. If we want to register it, we typically jump inside app module, and here we are just adding it to the imports like foo module. But now the question is how we can provide some configuration inside our module. And in order to do that, we must write some code inside our class. And we're writing here static for root, which is a function, and here we must get some config. And let's write that we have some foo config. And our root function returns for us module with providers of our module, which is our foo module. Now inside this function we must return the object with ngModule property, which is the link to our module, so foo module, and here we have our providers. And in our case here we want to provide here a service where we can get this config. This is why here I will write foo service, we will create it in a second. And as a second parameter, we must provide an object with provide property of config, and here useValue will be config. So this useValue config is coming from here from the parameter, which actually means outside somebody will provide for us a config which will suit our foo config. And now here we are saying, okay, through this config, we will get a value inside our foo service. So now here inside our module, I will create foo service.ts, and here we have our injectable as always, and we're exporting our class, and it will be our foo service. Now here, first of all, we must create a property where we will store our config. So let's say that we have here our config, which is by default not there, of type foo config. And now here we are declaring a constructor, and inside this constructor we want to use inject, and we're injecting here our config. And this is a private property which is config of type foo config. And now inside we can simply throw inside this config our foo config that we just got from the configuration. The last point that we're missing is our foo config. So here I can create foo interface ts, and it will be our config. So here export interface, and let's name it foo config. And let's say that here we will get API URL, which must be a string. Now here, everywhere we must import our foo config, so we have it inside our foo service and inside our foo module. And also we must import here our foo service. So what is happening now, we defined a foo module where we must provide a foo root. And if we are providing foo root, we must provide this specific config that we are waiting for our foo module. And when we are providing it, we are giving it inside our foo service, and after this we can use it anywhere inside our module. And now here we can change our code in app module, because here we have just foo module, but now we have dot for root, and as you can see we are providing inside foo config, which actually means here we must have a property API URL, which is mandatory for our config. For example, here we have HTTP localhost 3004. And now this API URL is coming inside our foo module, this is here, and now here we have our foo root, and we are throwing this property inside our foo service. This is our foo service, and we can just console log it here to check that we really have it. As you can see here, we're getting an error that property config is exactly the same. This is why here let's write that this is our foo config, and we want to store it here. Now, in order to test that this stuff is working, we must use somewhere foo service, for example inside app component. So here we can just create a constructor and register here foo service. And this is our foo service that we already have. And now here I want to console log what we're getting. This is our config, and it is coming from foo service dot foo config. Let's reload the page, and as you can see we're getting config twice. It is console logged inside foo service in the constructor, and second time inside our app component, which actually means we successfully passed a config from the outside through foo root inside our foo module and foo service, and now we can use everywhere our foo service, and we know with what configuration our foo module was created. You might get a question like this: what is Angular SSR or server-side rendering, and what are the pros and cons of using SSR? So actually this question is not related just to the Angular, but any front-end framework where we can render our code on server-side. And actually in the web we have two different ways to render our application. It may be server-side, where we're just rendering an HTML page and you can inspect the source code of the page and see the markup there, and client-side, which actually means we're rendering the whole page with the usage of JavaScript. And then when we inspect our page, it is completely empty. You typically have there just a body and one single root element where the whole JavaScript application is being rendered. So the question is now, what is server-side rendering? And actually server-side rendering is the idea that we want to render our client-side application like Angular or React or Vue not only on client-side but first of all on the server, which actually means you typically will have Node.js on the server, and there you will read all your client code like Angular, all modules and components, and build from that an HTML page. And this is exactly what you want to get from the server to make your project server-side, which actually means you are rendering first your project on the server side, and then you have your project on the client side, where you are binding all these events to your page and make it interactional with JavaScript. So the main question is, why do you want to do that at the first place? And from my perspective, it is important to remember that almost all client frameworks doesn't really need to be rendered server-side. By that, typically you have just two cases where you want server-side, and the most important for them is that your website can't be parsed by search engines like for example Google, which actually means if you're making an Angular application and you have there a list of posts, then Google can't really read them, because you are rendering them on the client side with JavaScript, and inside server side you have the empty page, so search engines can't read them. But the main question for you then, why are you using Angular to render a list of posts? It might be much better for you to just use some backend language and render your data, because we're writing single page applications where we have a huge and difficult state with lots of interactions on the client. So here we're talking about applications. We're building applications inside web where a lot of things must happen without page reload. Rendering the list of posts or jumping between categories of online shop is not really a client-side application. So as I said, in 90% of the cases, for your client applications you don't need server-side, because you are building difficult client application and you don't really want to render it on the server. But there are two cases where you want that to do. And first of all, I already said it is SEO, where you want your code to be readable. And second use case, you really want to show something for the user when they are loading your page. Because with JavaScript your page will remain empty, or at least you will see there just loading, until JavaScript will be loaded, parsed, executed, and then it will render the page. So again, if you want to render Angular application on the server as server-side rendering, it is completely possible. There is an additional package for that, and the idea is that you have a node application on the server which reads your whole Angular application and renders the HTML page from it. After this, you are loading your client side as always, which actually means all your events are binded there, and after the initial rendering, you are working completely on the client side. You might get a question like this: how we can execute code outside the Angular change detection? When does it make sense to do that? And can we write a small example? And actually the first question already shows us that we are talking here about ng-zone. What is ng-zone? This is a possibility to run our code outside of Angular. So Angular doesn't know anything about our code, and it simply does not trigger any change detection for it. And sometimes you have cases where you don't want to trigger change detection of Angular every single time. For example, when you are implementing drag and drop, or when you need to calculate mouse positions lots of times. To improve performance, you are moving your code outside of Angular. Another case when you want to use ng-zone is when you are using some third-party library. For example, you have a library which was not built for Angular but for plain JavaScript, and then you are running this library outside the whole time, and then at some point you are simply syncing the result of calculations to your Angular project. In this case, ng-zone is exactly what you need. Now let's create a small example and check how it works. So here I am inside app component, and I want just to create here one more div with word element inside. And on this div I want to add mouse down event. And here we will call mouse down function, and we are passing our event inside. And additionally to that I want mouse up function. And here we are calling mouse up function where we are passing event. And the last thing that we want to add here is the reference to our element, and we will use it in order to get native element inside our component. Also here I want to render the position of our cursor, because what I want to show you is actually drag and drop, which means mouse down, then we're holding it, we're registering mouse move, and then we have mouse up. This is why here I rendered position, but it will be either undefined or an object. This is why I'm rendering it like this. Now we can jump inside our component, and first of all we want to access our element. This is why here let's use viewChild to get our element. And here we can say that static is true because this element is always visible. And here everywhere I will use any just to simplify typing, because I want us to focus on this logic. Our next step here inside constructor is to get zone. And what is zone? This is ng-zone that we are getting from the Angular. Now here with the zone we can use run outside Angular and just run to run code inside Angular. Now here we want to register three different methods. First of all, mouse down, and we're getting here an event, which will be any. And again, obviously you should not use any in production, but this is just for our code. Then we also register mouse up, and additionally I will have here mouse move. And the main idea is that we want to call mouse down and mouse up inside Angular, but mouse move outside Angular. This is why here is our code. We want to call this zone run outside Angular. And inside we are providing a function that we want to run outside. And here what we want to do, we want to add an event listener to our DOM. This is by here, window, document, add event listener, and inside we're providing mouse move, and here will be our listener. This will be function, this mouse move that we just created, and we need to bind it to this, which actually means this line will be executed just in plain JavaScript without Angular at all, and Angular won't do any change detections. Now here inside mouse move, what we want to do, we want first of all to call event prevent default, and after this we want to store the position of our mouse inside our DOM element without Angular. This is by here, this dot element set attribute, and here we want to set x, which will be event.clientX, and the next line will be where we're setting y for client y. So again, this code is outside of Angular, this is just JavaScript, and we're updating our DOM element. And now here we have mouse up, and here we want to run our code inside Angular. This is why this zone run, and again we have a function inside with our logic. And here we want to assign something inside position property. And we didn't define position here, so let's define it. I will simply write any, but actually it is either undefined or our position with x and y. And here inside x we can write this dot element get attribute, and here we're reading x, and after this we want y, where we're reading y attribute. And after all this code we must remove our listener from the JavaScript. This is by window, document, remove event listener, and here inside we're providing mouse move, and as a listener we will have our mouse move function that we binded previously. This is extremely important for memory leaks because with every single mouse up we want to remove our listener. And the last thing that we forgot to do, we forgot to set this element, and we must do it inside our mouse down. So this element must equal event.target. Let's check if it's working. I'm reloading the page, and let's look on the Elements tab. Here is our div, and now I'm just clicking, but I don't have up. And as you can see with the movement of my cursor, I get x and y as two attributes inside DOM. But most importantly, as you can see, these are lots of changes, but it is really easy for JavaScript. Angular will trigger detect changes for every single change with mouse move, and this is not the best approach. So here we're moving a lot, and then at some point we have mouse up, and as you can see, only now Angular rendered something. This happens only now because before this, before our mouse up, mouse move didn't trigger Angular detect changes, our code was outside of the Angular, and only inside mouse up, where we're running ng-zone, we assign this position inside Angular where we're reading a value from the DOM, and this is why it was rendered just a single time. But just imagine how many re-renders we will have if we will write mouse move function inside Angular. You might get a question like this: what forms do we have inside Angular and how do they differ between one another? And actually in Angular by default we have two different types of forms. We have template-driven forms and we have reactive forms. And actually from the start you must understand that these two solutions are not equal, because actually template-driven forms were mostly created for the people who were migrating long ago from AngularJS framework to Angular framework. And if you don't know, Angular, when we are talking about Angular nowadays, is Angular version 2, and this is not the same like old Angular framework. This is why we had template-driven forms. With these forms, it is easier for people to switch to Angular because they are not reactive and they are written in simple way, like forms inside AngularJS. But actually the main problem is that these forms are really limited, because you are creating the form inside your HTML and you can't just write some values inside HTML. Essentially you can't access your form inside your TypeScript file, and you can't really write all this reactive logic inside your component. As you already know, Angular is heavily based on React.js. This is why it makes a lot of sense to use reactive forms. And this is much better approach, and if you are just starting on using form, it doesn't make any sense to take template-driven forms. It is much easier to start directly with reactive forms and stick to them. And the main idea is that our forms are reactive and they are built with React.js. This is why we can access streams inside these forms and combine different values together to create different new streams. Additionally to that, we can combine streams from our forms with the streams of React.js from other places. This is why it is extremely flexible, and these forms are enough to create forms of any complexity. So we don't need to install any additional package in order to use any of these forms. This is why here I want to create a form inside our app component HTML. As you can see, I don't have anything here, but first of all we're starting with our TypeScript file. And what we want to do, we want to get here FB. And what is FB? This is our import, which will be form builder. Now here on the top we can create a form, and let's say that we're implementing form for our registration. This is why here we will have register form, and here we can write this.fb.group to create a form. So we're using formBuilder.group to create any of our forms. And inside we must provide all possible fields which will be implemented inside our form. First of all, here we can provide user name, and we can just set here a default value as an empty string. But this is not all. Actually, inside our forms we can add validation. As you can see here, we don't have any validation, but we can easily add it. This is why here we can write that we have an array, and as a default value we have an empty string, but after this we can add our validation. And for this I will write validators dot, and here is a rule. And as you can see, we have lots of rules and we can use any of them. Typically you will use such rule as required, which actually means our field must be required, so our form will be valid. And in exactly the same way we can create another fields. First of all, here we need password, and it is also an empty string and it is required. And the last one here is email. And it will be not only validators required, but we also want to have here a valid email. This is why here we won't provide just a single validator, but an array of validators as a second parameter. And here I can write not only validators required, but validators.email. In this case here we are sure that our email will be correct, and we don't need to write any checks by ourselves. And this is already enough to build our markup. This is why here let's jump inside our HTML file, and here let's create our form tag. What we want to write now here is form group, and this is an attribute where inside we must provide a form group that we just created, and it is our register form. Additionally to that, we want an event when we are submitting a form, and this is ng-submit. And here we can create a function on submit, and we should not provide anything inside because we will have everything that we need inside our form group form. Now here inside, let's create a label. So here we will have input type text, and we want first of all to have here a username, and we're adding here form control name. And this is an extremely important attribute because this is how we are binding our reactive form with HTML. So I'm providing inside username, and now the changes of this field are going directly inside the field of our form. Now let's wrap our input with a div so we have a nicely readable form. And I want to copy paste this div 2 more times just because we have an email and password. So as a second form control name I will write email, and as a third it will be password, and type will be also password. Now at the end we must create a submit button. This is why here one more additional div, and inside we have a button with type submit. Let's close our button and let's name it register. As you can see in browser, we are getting an error cannot bind to form group since it is not a known property of the form. It is happening because inside our module we didn't inject reactive forms. So what we need to write here is reactive forms module. And in this case we won't get any errors. But here now we're getting an error, property on submit does not exist on type app component. This is totally correct, we didn't create here our function on submit. And this function should not return anything, but we just want to console log the result of our form. So let's write here on submit, and here is this dot register form, and here we have value. Let's check in browser. As you can see, we have 3 inputs. First of all, our username, then our email and our password. I'm hitting here register, and here inside console log we see on submit, and here are our values from the form, username, password and email, which actually means we successfully created reactive form and binded it to our component. What is more important, now we can write here this dot register form, and we have such values like invalid or valid. As you can see here, I want to know if our form is valid. And just after page reload, if I will click on the register, we are getting false, and this is totally correct because our fields are wrong. Only if we will not only fill our fields, but also provide a valid email, only then our result will be true. As you can see here, on submit is true, and now we are getting correct values, which actually means we are getting out of the box working form. We can just style it and it is working. And we don't even need to install additional packages. But at some point you want to show your client validation. And actually the whole validation we already have inside register form, we just need to render it. What we can do here, for example, after the input, we can write a span. And inside this span, we want to render an error, for example, when our field is required, but it is not filled correctly. Which actually means here inside we can simply write this field is required. And now here we must add an ngIf condition. And actually here we want to know that we have this error. This is why we're writing here register form dot get, and we're getting here the access to our specific field. In this case it will be username, but it might be that we're getting undefined because this value is not there. This is why we put question mark dot, and here is invalid. This means that we will show this span every single time when this field is invalid. As you can see in browser, we are getting this error message just from the start, but maybe we have more validators, which actually means we want to show this field not just when this field is invalid, but when this error is there, which actually means instead of invalid, we can write here has error, and we're providing inside required. In this case, we will exactly show this span only when the error is required. And yes, now this field is still there because this field is not correct. But the main problem is you don't want to show client validation just from the start. You want to show it when we submitted the form or changed the input. This is why here, additionally to this if, we want to write here and check for dirty and touched. This is why here register form dot get, and we're getting here our username dot dirty or register form get username dot touched. And now here we must write round brackets around this condition, which actually means when our form has error required and our input is either touched or dirty, we will see this error. As you can see in browser, by default this error is not there, but after I will hit on this field or change this field so it is touched, we are getting the error this field is required. If we will change it and it is valid, then we won't show this error anymore. But additionally to that, as you can see, we wrote quite a lot of code. And just to imagine, we will duplicate this code for every single validator and for every single field. It is quite a lot of code, but you can easily move all this code to additional helper. For example, you are creating a function which will render an error message, and here you are just providing what error you want to watch. And then you will simply call this function everywhere. But just for the sake of understanding, I will leave it like this. And the last thing that I want to show you here, when we're clicking on register, we don't see our validation. Why is that happening? Because actually our username is still not dirty and it is not touched. This is why we are not showing this error. But in order to fix this problem, we can simply create additional property is submitted. And actually this property doesn't have anything at all to do with our reactive forms. This is just a property, and here in onSubmit we can set is submitted to true. Now here inside our HTML we can just add this condition. So either our field is dirty, touched, or it is submitted. Let's check if it's working. The page is reloaded, we didn't type anything, I'm hitting here register, and we're getting this error message. And previously without is submitted, we didn't get it. And the last thing that I want to show you is why all our forms are reactive. So what I want to do here, I want to write implements on init and create here after our constructor ngOnInit function. Now here I can write this dot register form dot, and I'm using get just like in HTML, and we're getting here our username. Again, it can be undefined. This is why here I will put question mark, but after this we have value changes. And actually value changes is an observable of our field, and now we can use it as an observable. For example, here I can write .subscribe, and here I'm getting the value of our username. And I want just to write here console log value changes, and here we have our value. As you can see in browser, I don't have anything, but now every single time when I'm typing something inside this input, I am getting console log, which actually means we can use get field and then dot value changes to get access to the stream of some field, and then we can combine the streams or merge with different streams even outside of reactive forms, which is extremely flexible. You might get a question how to fix such error. And as you can see here, we're getting an error property current page has no initializer and is not definitely assigned in the constructor. And here is the code. We have here an app component with current page, which is a number, it equals 1. And we're rendering here in the template child component, and we're passing inside our current page, which was a number. Now here is our child component. Here the selector template, and we just have an input with current page number. And we're getting here an error, property current page has no initializer. The main problem is here that we didn't assign default value and it is undefined. And actually for the component it is not that comfortable because we want inside the component to work with number, which actually means we're writing here, for example, constructor, and we want to be sure that our current page exists. For example, we're making here this current page plus 1, so this code must work. The main problem is here that we don't have default value. This is why we can't be sure that this value exists. It can be that from outside we didn't pass the value, or another programmer didn't pass it. This is why here the easiest solution to this problem would be to set a default value. This is why here we can simply write equals 1. But you can't really do this in all cases, because sometimes this is not what you want, you really don't want to set some default value. This is why here are several solutions for that. First of all, I want to show you what to do if you have a string. And typically you have strings a lot and you don't really want to set them to something. This is why here I highly recommend you to write like this. For example, we have a full string, but we need initializer, but you really don't want, you want it to be provided from the outside. What we can write here as a default value, we can write here not set. In this case, when other developers or you would use this component somewhere, they will see inside some string not set, which actually means your component won't be broken. You will directly see, okay, component is working, but I didn't provide this specific string, and they will change this. This is a nice solution to avoid undefineds, because undefineds are bad. Because in every single place of our component we must check is it undefined or is the value there. And this is a lot of code. For example, here, if we will say that our current page can be undefined, we can simply write here question mark and number. This is totally fine, and this is a good solution. In this case here, we can create some function, and now if we want to do something with current page, for example, current page plus 1, we want to check if we have current page. This is why here we can throw an error or simply return if we don't have current page. And now here I can just write console log this dot current page plus 1, and as you can see here we're getting that current page is the number and we can do plus 1. It is not undefined because we handled undefined case. But obviously this is not that comfortable to write your code like this everywhere. This is why I prefer to use default values when it is possible. If not, I'm writing here undefined. And now here I want to present to you two solutions that you should never use, because they are really bad, and if you will show your solution like this on the interview, then you will for sure fail. First of all, people would write here any, and we're ready with that. It doesn't really matter what we're writing here, we won't get any errors, because we don't have any checks. It is any everywhere, and our TypeScript is disabled. As you remember, any is bad, you should not use it anywhere. Another solution that I see a lot, people simply disable this error inside their tsconfig. So you can jump here in the root file, inside your tsconfig.json, and here you have lots of rules. And somewhere at the end, inside compiler options, you can write strict property initialization and it equals false. With this rule, you won't see this error. But this is obviously a bad approach because we want our code to be as strict as possible. The same goes with the rule strict true. You want to have strict true in your application if you can. You might get a question like this. Are you familiar with Redux or NGRX? And actually Redux is a really huge topic together with NGRX. And I would say that this is an optional knowledge which goes on the top of Angular. Because it is not related directly to the Angular, but because NGRX is widely used as a state management system for Angular, you might get such questions. And realistically, this is a really huge topic which I can't cover in a single video. This is why in this video I just want to show you how to implement a single module by using NGRX so you can see how it is done at all. And then at least you have some understanding how NGRX and Redux are working. So the first question is, what is Redux? And actually Redux is a framework that you can use with any framework. And as you can see here is just a single line, a predictable state container for JS apps, which actually means this is some global state which is available from your framework outside, and you can somehow communicate with the state, change the state and get updates. But there are quite strict rules and quite a lot of knowledge that you need in order to master Redux. So we don't use directly Redux inside Angular, we're using it through NGRX. So what is NGRX? This is actually the implementation of Redux inside Angular. So it is done completely in an Angular way, and this is the most popular library on the top of Angular. And what it does, it simplifies for state management. Why do we need that? Inside Angular we simply have components or services, and we typically put all our reusable stuff inside services, but we don't have there any strict rules, so when several developers want to work together, this is really difficult and the code is really low level and all people are writing it differently. Inside NGRX we're writing lots of boilerplate, but all this code is looking the same in all projects. With this approach, any developer can understand what is done and can adjust this code easily. So to start working with NGRX, we must install it, and there are several packages here, like for example NGRX Store, which is the basic package, then we have NGRX Effects, Router, Entity and so on. Most importantly is this version. As you can see, the stable version is 15 because our latest Angular at the moment when I'm recording this course is also 15. And actually here inside our project you must jump to package.json and here check Angular version, because you always want to have exactly the same version for your Angular and for your NGRX. If you will have different version, you will have some problems, collisions, and you don't want that. So I have 15 version, and here we have 15 version of NGRX. This is why I can jump inside console and install, first of all, NGRX Store. So here I can write npm install add NGRX Store latest. And additionally to that, we will use effects. This is why here npm install NGRX effects latest. But in order to debug our application easily inside NGRX, we're installing one more package. This is why npm install add NGRX store devtools latest. As you can see here, we don't have any errors, and now let's see what I have in my application. And actually inside source app, I already prepared for us a folder users. And actually this is a module. As you can see here, we don't have anything here, but we're just rendering it inside our home page. And as you can see, we're declaring here users component and users service. So what is inside component? Nothing. This is just an empty component. And inside service here, I have just an API call on my API, which I have locally, to get the list of users. And just to remind you, we're using this db.json here in the root to return for us a list of users. And here inside console, I can just write JSON server watch db.json, port, and this will start my fake API, where on localhost 3004/users I am getting back the array of users. And this service does exactly that, and there is no NGRX code yet inside our application. As you can see, the last thing that I have here is user interface, and this is lying here inside types, user interface. This is just ID, name and age. So the main idea now is to implement the list of users inside our application by using NGRX, so you know how NGRX is working. First of all, we must jump inside our app module TS, because here we must inject store module, and this is the main module from NGRX, and here we must call it with for root, and here we're providing an empty object. Additionally, we want to inject here DevTools. This is why here store DevTools module dot instrument, and inside we're providing an object, and we're providing here max age 25, which means inside our DevTools we will see maximum 25 records. Now log only, we want to see only logs inside production. This is why here let's write false and auto pause true. So this is the configuration for our DevTools module, and this is the configuration for our NGRX module. It is important that here we don't register anything, because what we want to create for our users is related for our users module. This is why here we will register something in isolation for our NGRX. And what we want to register here is a reducer. What is the reducer? This is just a state that we will use for this specific module. This is why here I am creating store folder, and inside the file reducers.ts. Now here, first of all, we must define what state do we need. And typically you will have such state inside service, but now we have it inside NGRX. So here we can define the property initial state. And here we typically need three things. First of all is loading, and by default it will be false. Then data, by default we have an empty array, and also error null. And for example, when we want to show spinner, this is loading true. Here we will write our data that we have, and error we need if we want to show some error for the user. The main problem is that we didn't create a typings for our state. This is why here inside our users, inside types, I want to create interface for our state, and it will be in our case user state.interface.ts. Now here let's register our interface, and this is users state interface. What we have inside first of all is loading. This is our boolean property. Now here we have data, which will be our user interface array. We already have this interface. And the last one will be error. It is either string or by default it will be null. So our interface is ready. Now we can use it here inside our initial state. So we successfully defined our initial state. Now we want to define reducer. What is reducer? This is a function where we define how our actions are changing our state. So what is action? This is just some function that will change our state. For example, get users might change our state. Maybe clicking on the button is also an action, and we will change the state. This is why here we can create our reducers. And here we're using a function create reducer. As a first parameter, we're providing here initial state, and then on every next parameter, we're using here on, where inside we must provide an action on which we want to react. But the main problem is we didn't define our actions yet. This is why here inside our store, we can create a new file, and we can name it actions.ts, and here we will create our actions. So here let's create export const get users, because this is what we are getting. And here we can use a function create action. And inside we just provide some unique string, because this will be our global function which will change our state. So here we can write users get users. And if you are wondering why I wrote like this with such namespace, because this is exactly the namespace. Our module is users, we're rendering users, and with this case we can directly see to what module this action belongs. Now we can jump back inside our reducers, and here we can create with on a reaction. So here I have on, and we're providing inside our users action. And actually here I want to import them with star, because I need all of my actions. So I'm writing import star as users actions from, and here is the list of actions that we created. Now here inside on, I can write users actions dot get users. So inside on, we're reacting on this get users, and as a second parameter, we're doing something. So here we're getting our state, and we can change the state. So here I'm spreading the state, and I'm just writing is loading true. So what it does, inside create reducer, we're defining initial state, and we will define a lot of on methods. And on means that we're defining how we're changing the state. For example, when the action get users happens, then we want to change state like this. As you can see here, we're getting access to our state, and here we're returning the new state. Inside reducers, we can't mutate our state. This is why here I just create a new object, I take all properties of our state, and I'm overriding here is loading true. And it makes a lot of sense because now with get users, we're starting the process of getting users from API. And this is a long process, and inside this process, we want to show a loading indicator. This is why we're setting is loading true to change our state. So our reducer is ready. Now we can jump back inside our module, because here inside imports we want to register it inside NGRX. And in order to do that, we're writing store module, but not for root, but for feature. And here we're writing the name with which we want to register it. As we have users module, I will write here users, and here I am importing reducers that we just created. So this line is important to create our reducers. Now we can jump and see that we don't have any errors, and I want to open a browser. And as you can see here on the right, I already have the installed Google Chrome extension, which is called Redux. And actually you can just download it for free, and now you are getting this tab. And here we have everything that we need to debug our NGRX application. Here we can click on the state. As you can see now in browser, our state is not empty. Here we're getting this users property with data inside, and we have here is loading, data, and error. So actually what we have here is the global state that is available everywhere inside our application, and we can use this data and change them from any place. And actually we did that just with this single line when we're registering our new feature users with this reducer. And this reducer is exactly the slice of the state that we created. So here we have users, now we can have something like basket, feed, homepage, whatever you need. The next thing that we need to do, we want to dispatch our action. What does it mean? We want to call it. This is why here I am jumping inside components, users, user component, and here I want to add implements on init. And actually we want on initialize of our components to fetch the list of users. This is why here ng on init, and here we want to dispatch this action. This is why here we have a constructor, and we're writing here that we have a store, and this is a store which is coming from NGRX. But here we have a problem. As you can see, we are getting that the store is T object. And this is really not good for our application, because we want to define with TypeScript what data we have inside our store. Which actually means we want to describe the global state of our NGRX application. And we are doing it in source app, and here we can create types because these are global types. And here I will create appstate.interface.ts. And again, this is a global state of our NGRX application, so all people can see what properties we have inside. And here I want to export the interface, which is app_state_interface. And here inside we for now have just users, which is our user state interface. Now everywhere we can just use this interface when we need to define what we have in state. This is why here instead of store, like we wrote here, we can define store of app state interface. And in this case here, everybody know what properties we have inside. Now in order to dispatch the action, we're writing this .store dispatch, and inside we're providing our actions. And actually here I will write them exactly the same, import star as users actions from, and here is the path, store actions. And now here inside our dispatch we're writing users actions dot get users, and we're calling this function, which actually means we're not just calling the function like get users, we put it inside this store dispatch. And we're doing it always when we need to change our state, because essentially this thing will change the state. Let's reload the page and see. I am reloading the page, jump into the Redux, and here you can already see users get users, which actually means on initialize of our component, we dispatched the action and we can see it here inside our DevTools. And as you can see on the right, we can see the div, how this action changed our state. And we can see that users is loading is changed from false to true. And when we're clicking on the state, we can debug that users is loading here is true. And as you can see, it is extremely easy to debug Redux and NGRX because your whole global state of the application is here. You can see all actions and you see how they change your application. So now you know how to dispatch action and change your state. But for our case it is not enough because here we want to do something what is called asynchronous actions. Why that? Because the call to API is an asynchronous process and essentially NGRX and Redux don't know anything regarding API. They simply dispatch actions and they are changing the state. But what we want to do, we want to have something like success action and failure action, and these two actions can change our state, and then we need to call them accordingly. And for this we have inside NGRX additional module which is called effects. This is why here we must jump inside our app module and here register it. This is why we're writing here effects module dot for root, and we don't provide anything inside. The next step would be inside our users, store actions to define all actions that we need. We already have get users, we must create get users success and get users failure. And actually inside success we can change the name here, get users success, and the name doesn't matter, this is just a string. But as a second parameter we must provide here props, because from the backend we will get a list of users. This is why here we can write props. And here we must provide how they look like. And it is always the object, and in our case we can write that we're getting the users, and this is user interface array. So as you can see inside create action we must provide a string, this is the first parameter, and we can provide props to specify what we must provide inside this action. And in this case here we say, okay, we must provide props, and we will get inside users array inside users property. And exactly the same we will do with failure. I will just copy paste it and change this is get users failure and here get users failure. And inside props we might get some error. This is why here I will write an error property. And here as a value I will just write string, because this is what we have in our state. So all our actions are ready. Now we can jump to our reducer and say how these actions are changing our state. So I will copy paste on again. And here we will change get users to get users success. And here we are not getting just a state as an argument, but as a second argument will be action. And here we can merge state with this loading false because we want to change it back. And here we will have data inside action dot. And as you can see, I have autocomplete for type. This is our string. And here I have users, which actually means I'm taking our users from the action.users and I just update them inside the state. So as you can see, we're defining in the reducer how the action is changing this reducer. And now we're doing exactly the same for our failure. This is why I will copy paste it and change it to get users failure. And here we have our state action. Here is loading is false and we don't change data but error, and it will be action.error. So our reducer is ready, and now we're coming to the most difficult part where you need some knowledge of RxJS. This is why here inside our store we can create a new file which will be called effects.ts. And actually what is an effect? This is something that we use for a synchronous process. For example, when we're calling a service which has an API call inside. And the main idea is that our effect waits when some specific action will be dispatched. In our case, it is get users. When this action is dispatched, then our effect will start to call the service where we have an observable which is a long process, and when we will succeed, it will dispatch an action success or it will dispatch an action failure. This is why here we must write injectable on the top, and here we want to export our class which will be users effects. And here inside we're defining a property, the name doesn't matter, get users with $, because it is a string, and here we're writing create effect. And inside we're providing a function, and we will use actions. This is why here we must inject them here in the constructor. So here we have private actions with $, and here this is an actions which are coming from in grx. And additionally, we must inject here our service. So here we have users service, and this is our users service. Now we can write our effect. So here inside, first of all, we're writing these actions, and this is actually a stream with all our actions. But we just want to get one. This is why here on the top we can import our actions. And here I will import star as users actions from, and here we're getting our actions. So after this we can use this actions $.pipe, because we always must write pipe. And inside I will write of type. And what of type does, it listens just for the single action. So here we can write users actions dot, and here we're listening to get users. And when this happens, we want to make an API call, and we're making it inside merge map. And here inside we have a function, and we want to return here an observable. This is why here we're returning this dot user service dot get users. And actually this is an asynchronous API call. This is why here we must react to it. And this is why we have pipe and inside map. So if everything is fine, then here we get back our users and we want to dispatch our action. This is why here we're returning users actions dot get user success, and here inside we're providing an object with users, which is our users. And as you can see, we don't have any errors. If everything is bad, then we must write here catch error. And inside our catch error, we're getting an error, and we want to return the action. This is why here we're writing off to wrap it in the observable, and we're providing inside users actions dot get users failure, and we're providing an error inside, and this is our error.message. And I know for sure that effects are looking really scary, and then you don't really understand a lot of the code here. But the good part is, this is exactly the same code that you will copy-paste again and again every single time when you need an effect. You will write create effect, you will write here pipe of type, you will listen to some action, and then you will use, for example, merge map with the service and API call inside with map and catch error, which actually means this is the 100% the same code every single time. You just need to learn it, and it will fulfill almost all your cases, except of some super complex and difficult logic. So again, just for your understanding, here we're registering effect, and it will wait until we're dispatching users like this, and it will make an API call, and if we succeed with this API call, then it will dispatch success action or it will dispatch failure action. But now we should not forget to register this effect inside our users module. Here we already use store module, now we must write here effects module. But here we also use for feature and not for root, and inside we're providing an array with our effects. And here we have our users effects, which are coming from effects that we just created. Let's check if it's working. As you can see, we don't have any errors. I am jumping to the browser, and now we see here two actions. Get users, this is what we dispatched, and here get users success. And actually this is what effect dispatches for us. Why is that? Because here inside network you can see that we have an API call to localhost 3004/users to get the list of our users. And here inside Redux you can directly see what happens. We have here get user is loading true, we got successfully the list of users, and this is how the data are changed. This is loading false, and here is the data with all our objects. And this is how our state is looking like. Now it is filled with users data that we can reuse anywhere in the whole application. You already learned almost everything, we just need to tackle selectors. Why do we need selectors? Because inside our components we somehow want to get all this data and render them on the screen. This is why let's jump inside users store and here create a new file which is called selectors.ts. And here we want to define what properties and how we're selecting. And first of all, here we want to write that we have a function select feature. And actually this is just a helper function to get access to this specific user's namespace. And here we're writing that we have a global state and we already defined it. This is our app state interface. And back we're getting state.users. Now here we can define every single selector that we need. First of all, here I will define isLoading selector. This is why I'm postfixing it with word selector, and we're using here a function create selector, where inside we're providing as a first parameter select feature. This is this helper to get state users, and then we're defining how to get from the state the value that we need, and this is state.isLoading. And as you can see, we're getting a nice autocomplete. Now I will copy paste it twice because we also need a selector for our data. This is our user selector, and we're getting here state.data, and here we have our arrow selector, and this is state.arrow. So this is exactly how we're creating selector in order to access this data in any component. Now we can jump inside our component and use it to render data. This is why here on the top I want to define observables. So first of all, here we have isLoading, which is an observable of boolean. After this we have an arrow $, and this is our observable of string or null. And the last thing that we need here is a list of our users, and this is our observable of user interface array. As you can see, we are getting the error that they all have no initializer, but this is not a problem. We can do it directly in the constructor. So first of all, isLoading, we're assigning here this store.pipe, and here inside we're using select. And inside select, we're writing our isLoading selector that we just created, which actually means if you need some information from the state inside your component, you are always writing the line like this store pipe select, and here is your selector, and this is your observable, which is filled with the information. Now I will copy paste it twice because we need to fill here our arrow, and this is our arrow selector, and also our users, and this is our user selector. And actually this is how you are getting information inside your component. Now all these are just streams that we can render inside HTML. So let's jump inside our HTML and write here something. For example, h1, and here we can write users. After this we want to render our loading. So here let's create div with text loading, and we're rendering here within gif isLoading stream, and we're using for this async pipe. After this we want to render an arrow. This is why here we have a div, and we also are rendering in gif for an arrow stream with async pipe, and here we're using as arrow, so we're getting this as a local property, and here I'm just rendering an arrow. So we're rendering loading if it is true, we're rendering an arrow if it is not null. And now we need to render a list of our users. This is why one more div here within g4, and here we have user of users, and this is a stream. This is why here we're using async, and inside we want to render our user.name. So as you can see, the code after ngrx is looking really nice inside template. As you can see, we don't have any errors, and here inside editor you can already see John, Mike and Jack. These are our users from the API. If I will reload really fast the page, you can see that loading is blinking there, which actually means the loading spinner is there, and if our API request would be longer, we will see a loading spinner. This is exactly how you implement ngrx in almost all projects. The main point is that the code is looking exactly the same everywhere, even in different companies. You successfully finished my course regarding Angular interview questions, and I really think that you are awesome and you learned a lot. If you just watched the videos and didn't write any code, I highly recommend you to pick randomly lessons and check if you really can answer that questions. And additionally to that, I want to remind you to not be upset if you will fail the interview. It doesn't really matter because with time you will get better and you will find your job. I hope that you really liked my course and learned a lot, and I will see you in my next course.